Professor Pai, can you hear me?
Good morning. Good
Good
morning.
morning, sir, and welcome to our institution for this occasion. And shall I start, sir? Are you okay with everything, every system? Have you checked?
Okay, okay, you can start. Good morning, Professor Pike.
Yeah, good morning. Good morning.
Good morning. Good morning.
So today you have two consecutive sessions.
Yes.
How you have designed it, or shall we speak on the first session, and then you will have a second topic for the second session, or you want to continue the session?
I can continue the sessions.
Okay.
You can continue the sessions.
Okay, so you will take the questions after the end of the consecutive two sessions, right?
Yeah, yes, 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 yes.
Okay, thank you very much for your uh,
Yeah.
coordination and everything. So we start formally. Good morning to everyone. And today we have among us not just Professor Pike, he is known as an innovator and known for his entrepreneurship. We are really grateful and really, I hope that we will enjoy his um, innovative speech. But before I allow him to start his presentation, I must give a brief introduction. Professor Pike is a lead author of 36 patent applications. 18 patent applications have been granted, and many more are pending. And Professor Pike is his research group, Materials for Healthcare and Therapeutics Technology, is funded by IIT BHU and IDEPT, ACRB, CRG, ICMR, DBT, DST, UGC, BHEL, etc. Currently, Professor Pike is a life member of many scientific communities, member of the many editorial boards, and he is known for his entrepreneurship. He is a founding director of the two startup companies. One is the Trifund Healthcare Private Limited, which deals with nanomedicine for infectious diseases, and second one is known as Azad Healthcare Private Limited, deals with nanomedicine for career therapy. His career path that he traveled, or rather I say ran, from a very humble background, that is really inspiring. And now I would like to ask Professor Pike to start today's session. Thank you.
Uh, Good morning to all. Uh, what is your name? Thank you very much for your nice introductions. I could not read your name in the screen.
My name
Nivedita.
is Nivedita.
Professor Nivedita.
Nivedita. Okay.
Yeah.
Professor Nivedita, thank you very much for you have told a lot about me. Okay, not it was not necessary. Okay, good morning to you all. So first of all, let's say I'll be sharing my slides. Okay, to let me share, then I will be starting what I want to. I will share enter screen. Okay, is something is visible today? Okay, first I whatever I have sent the abstract. Okay, this was the abstract engineer nano polymers nanomedicine for the therapeutic application. Okay, how many of you are from the biological background? May I know very quickly? I found that 43 years among the participants.
Yes, I am.
Mostly,
My background is
mostly,
botany. My background is
mostly from
botany. I am
biological.
working in green nanotechnology.
Okay,
Yes, sir.
and I believe everyone's are doctorate. Okay, PhD, and everyone are the faculty members any of the colleges and university. Am I correct?
Yes, sir.
Yes,
Yes.
sir.
Yes.
Yes, sir.
Yeah,
Yes,
okay. Okay, and everyone are attached with the research work. Okay, and you all my colleagues. Okay, so apart from the colleagues, I will be asking, let's say, hope so that this has been, it's known actually, engineered nanopolymers, nanomedicine for therapeutic application. Now, direct my question will be there. What do you expect from me from this topic? What is your perception? Which type of topic I will be teaching here? Or not teaching, I will be sharing some knowledge. Okay, sharing some experience in last 20 years, whatever I have gained. Many of them are not from the literature. Okay, what type of information you want for me? Anyone can tell? Let's say now we are starting introduction, and then what you want from me?
Please guide us how to write a patent actually. I am working some areas where scopes are dear to patent, but some means some problems I am getting
Okay,
in the writing part and to support the things.
okay.
It is regarding to one is related to process, another is related to product.
Mm-hmm.
So
So I am
I need
noting
some
down.
guidance
Okay,
from
I
that
need
aspect.
some question from you first, and then according to that, let's say so many slides and so many things are
Okay, sir.
there, and according to your requirement, I can address. And let's say, and few of the things whatever I have planned, okay, that I will be in 3 hours. So let's say writing of patents. Okay. Second, anyone anyone's have some other expectation that I can deliver to you?
Yes, sir. Dr. Orunima Dotto, she mentioned in the message box that nanomedicine preparation and delivery, insights about how to apply for patents
Okay. Nanomedicine preparation
and delivery.
and delivery. Okay. Delivery and how to go for patents. Okay. Okay. Next. Few questions first I need. Okay. Then I will be. And I want a survey that what you are expecting. Any others? Anything else?
Sir, I am Dr. Rajarshi Ghosh from the Department of Zoology, Maulana Azad College. Actually, I work in the aquatic ecosystem involving the geol fishes or freshwater fishes
Mm-hmm.
and the effect of some toxicants on the aquatic ecosystems and concerning the health uh,
Mm-hmm.
aspects. So,
Mainly
what would be the
toxicity.
applications of nanoparticles in the aquatic ecosystem so that we can improve the fish health?
So there will be involving the toxicity issues. Okay.
Yes, yes, sir.
Toxicity issues. Very nice. Anyone else?
Yes, sir. Another one, Dr. Abhijit Vishwas, he mentioned that what are the basic criteria to get or applying for patent? The same question almost.
Criteria for applying
Criteria to applying or to get the patent.
patents. Okay.
Yes.
Next, any question? I'll just.
Sir, good morning. I'm Dr. Namrata Rai,
Mhm.
and I'm an assistant professor of chemistry. So, sir, my
How long
I
you
mean,
are
what I
assistant professor?
sir, 5 years now.
Okay. In where? In which college?
Sir, Shantipur College under University of Kolkata.
Okay. Okay. What type of
Uh,
information you need from
Sir,
me?
because I'm from the chemistry background, I just hope to understand it from the chemistry perspective. I mean, not too much biological, not too much technicality in
So
biological
your
area,
requirement
so
is
that I
the
don't understand. Yes,
interface
yes, interface of chemistry and biology, and sir, about because
between
it is about
chemistry and biology. Okay.
and sir,
Okay.
because it is about nano medicine and about therapeutics. So
Okay.
how we can achieve targeted delivery and avoid non-specific interactions in nanotechnology and
Targeted
therapeutics.
delivery. Okay. Okay.
Thank you, sir.
Targeted delivery. Next, I need few questions. According to that, I will try to satisfy everyone. Okay. At least 70 to 80 talks are ready with me. Okay, I will be going one by one and I will be addressing. And at the end, I will be telling how to go for the filing of patent.
Sir, this is Azad Kumar Das from Guwahati, Assam.
Mhm.
I'm working as assistant professor in Department of Botany, Arya Vidyapeeth College, Autonomous. So regarding formulation, can you guide? Means
Formulation. Okay. Formulation of
formulation. We are
formulations
working
of,
more
let's say,
on
pharmaceutical product.
yes.
Pharmaceutical
So for
product
that,
or
for
the okay, very good, nice.
yeah, regarding formulation.
Okay, regarding formulas. Okay, few more question. Any other question in
Yes,
simultaneously you can
sir. Another question we received: a phytochemical delivery to target tissue.
phytochemical. Okay, phytochemical delivery.
Delivery
We
to
have done
target
it.
tissue.
Delivery to the target tissue. Okay.
Another question from Dr. Kaushik Sarkar. Know about toxicity of nanomedicine besides its beneficial effect.
Size and its beneficial effect, na? Okay.
Toxicity of nanomedicine
Mm-hmm.
and its beneficial effect.
Toxicity and its beneficial effect. Okay. Perfect. Very good. Very good. If okay, we will be continuously interacting. Okay, so that I can give you some informations about the domain in the cutting edge research, what is going on, and which will be helping you also. Those who wanted to write the projects will be getting some ideas about to write the projects and writing patents and the basic information. Okay, I believe that all of you are very good teacher. Okay, and but apart from that, we need in the time to time, even if you see, I have a son of 10 years, and if I am a age of close to, let's say, 45 or 50, my son is 50 years advanced to me. If I come advanced to me compared to the age whenever I was 10 years. Okay, we have to believe this. Okay, so similarly in the age of during the PhD, okay, or during our educations, we all perform very well. Otherwise, we or you, everyone cannot come up to this stage. Okay, but what happened that due to the lack of facilities, lack of supply of information time to time, our knowledge or expertise confined up to that level, sometime for many, and many we update regularly. Okay, that is the main understanding to have a refresher course. It is not only that the refresher course is the getting a certificate to fulfill the requirement of the promotions and other things. Okay, so that we have to understand. And let's say whatever the title of the topic I have sent, that let's say that's a just something else. Okay, that we according to your requirement we will not confine. Okay, up to into that. Okay, we can go somewhere else also. Now tell me whether my slides is visible to you or not.
Yes, sir, visible.
And I am just like this. I have so many slides I have opened. I will be going. Oh, this is very old. Okay, very old. Okay, this is my designation. Everything is there. Is very old. But I found that I usually go in the southern section and many places to give the informations to the teachers and the students what we will be doing. Okay, this is very old slides of fast because every designation has been changed. So only look after this polymeric nanomedicine, which is a word I have mentioned here, but some other nanomedicine we can also, okay, go and discuss further according to our requirement. Okay, fine. Let's say quickly we'll be going to the definitions what is meant by nanomedicine. Okay, if I tell very shortly, okay, what is the nanomedicines, okay, it's not actually very much new. It's a nanoparticles are known very from the very earlier days. Okay, if you go to a, let's say, synagogue, okay, in various places, you will see that the metallic colors are of different metals, okay, which is actually, if you see these things, concept of nano has come. If you see that, and whatever my pointer will be there, the places, okay, you just notice this has been taking a image of a windows from somewhere, let's say in European country, where the synagogues or the churches are there. Believe me that the colors has been made, okay, with, let's say, from the metallic particles by changing the sizes. Let's say gold. Now the gold price is very high, okay, but you see that the color of the gold is yellow. Fine, it is looking like similar. Whenever we wake up in the morning, the color of sun is quite red. If you see little bit later, yellowish, or if you see again, the time to time changes. So due to the reflections of light, okay, that can give the color of the materials difference due to a term is called the surface plasmon resonance, because the interactions of the photons with the electronic environments of the outer cells of the electron of nanoparticles, it's in such occur that what is the reflection light of reflection will be coming that's have a different, let's say, wavelength, and based of the wavelength it's give the different color, okay, because energy is equal to h nu, and nu is related to the wavelength. If you see that we have a very concept in the childhood time, whenever lizard work on the wall, we usually thought that what happened that the lizard, whenever it press, the air from the thumbpad, okay, come out and vacuum create, like the way also we put the hanger at the home. But actual happen that whenever there is a fibers are there on the surfaces of lizard or similar, whenever they press, okay, there occur the flow of the ionic liquids, and basically their atomic level interactions occur between the materials present on the wall and the materials present in the in the thumb pad. So whenever the distance between the two layers come below the, let's say, van der Waals wavelength, and not van der Waals, let's say atomic radius 0.5, okay. So whenever 0.5 nanometers and less than that, the distance are there, Bohr radius, this is called Bohr radius, then their interaction forces work much more between the two atomic environment, okay. And if you see that the figures of the peacock, okay, whether that is a color or something else, it has been found that in electron microscopy, it is made up of very, very tiny small fiber, and their orientations is different. And when the orientation is different of the feather fiber, we can readily communicate that or and compare that with the prism. When light fall on the prism, there is a separation of light occur, and based on the separation of the light, they create the different color. So that is a beautiful explanation from the nanotechnology, how the color generate. Similar way, if you see that, okay, the water drops on a lotus leaf, okay, lot of fiber actually there on the pillar of the fiber there on the surface of the lotus leaf, okay. Then what happened that the lotus leaves are hydrophobic in nature, due to these fiber stripes of the pillar, which are nanometer in size. And you see that this, the wherever where is my pointer is targeting, you see that reddish or pink color of some solution. Believe me that the solution is of the color of gold. Okay, so then what is coming, that whatever we see gold is yellow color, that is in the bulk stage, but whenever the size decrease to nanoparticles, into the nanoparticles, it's come below 100 nanometers. Okay, due to the refractions of the light, whatever the wavelength of the light diffract or refract from the nanoparticles, based on that, so we see the colors, colloidal solution. So the solution of the gold can be not only the yellow, bulk stages is yellow, and other cases will be different. Similar phenomena can be there in different sizes of the particles. Okay, now quickly I will be telling you something to the others, what actually happened. Okay, so let's say nanometers by definition is below 100 nanometers, because any of the materials of size above 100 nanometers, they will have the bulk property, bulk type. And what about the, now we have discussed the property, they are, let's say, they are going to the towards the property of the quantums. Now you see that, okay, one interesting example I will be showing, since some question was there, the targeted. Okay, I will be coming in each and every questions. So quickly I will be going to a, let's say, portion, let's say these slides, you see this. If you see these slides, okay, what I have shown there, okay, you see we have a body, fine, and let's say brain to skin to liver, spine, everywhere. They are different in cells because their cells structure are different and chemical compositions are different. Let's say the response of the cells of eyes and response of the cells of the kidney or some places will be different whenever some materials will be interacting with each and every part. Fine. Let's say we know everyone about the nanoparticles, dimension of the nanoparticles, everything are different. Okay. Now if you inhale, or if you eat, or if you engulf the nanoparticles, or say if you inject the nanoparticles, where the nanoparticles will be going? Where the nanoparticles will be going? If you see that if the nanoparticles reached in some places, or then it's mixed to the bloodstream, then what will happen? They will flow to the bloodstream, and they will, let's say, first they will be going to the heart, then let's say some every other parts will be, they will be going, and they will be going to the kidney, and everywhere will be giving. If you see this cartoon figure, you see the number of nanoparticles injected inside this body, and they are reaching to any of the organ. If you see that number are different. Okay, the question can be that why they are reaching in less number. Anyone can tell why they are reaching in the less number to the any of the organ? Let's start with the interaction. Anyone can tell why they reach a limited number in the organ? Why all the particles are not reaching to the all organs? Can you tell anyone? Anyone? Whether
Sir,
any?
sir,
Just
it's
interact.
Arunima here. So
It's
maybe due
loudly.
to non-specific binding. Hello.
Mhm.
So maybe due to non-specific binding to other areas, they could not reach the targeted organs.
Okay. Okay,
Or maybe
non-specific
lost in the
binding.
process.
Non-specific binding. Okay, very good and very good and excellent. Now you see that I will be telling a story. Then we can, let's say, if you see this story, concept of targets, how it's come. Let's say this cartoon has been taken from a love story. Okay, in ancient time. Okay, let's say one son of the king. Let's say prince and princess of other country are falling in love. Okay, and let's say similar situation occur whenever we are in the childhood or in the school or colleges. Many fall in love with some opposite sex. Okay, so usually what happened that time in the ancient age, let's say some king are there, or prince are there, or princess. It can be in opposite sex. So let's write a letter. Okay, this is a love letter. Okay, and to send the love letter, because there is no tendency like this, like we should send the WhatsApp or mobile call, or let's say postal service was not there. So usually what happened that time, they train the pigeon or some birds or something else, and they put the proper address on the letter, and is the pigeon or some birds trained in such a way that they could carry these to a proper position. But thing is that, let's say this pigeon is properly trained, carrying a love letter, it's reached to the, let's say, princess house, prince house. But whenever it's reached there, it's found that lot of crowds. Okay, a lot of crowds are there, and maybe many of them are similar looking, dummy type, looking like similar. And let's say then what will happen? Usually there will be confusions. Okay, to whom the letters will be given. Fine. And let's say letter reach to the others and open. Then what will happen? Obviously there is a rumor that if it is something confidential, the message will be going to the others. We suppose others should not know. Then it will be a, let's say it is a unwanted incidents will be occur. Okay, and suddenly. So this happened in the classes also. Let's say someone love letter has reached to other hand and the friends open, and we have so many experience that in the rumor will be there in classes. Similarly, one example you can take that, let's say my phone number, email ID, what we usually do, let's say if you see that in the whenever the mobile phone, only the letters was there. What you used to put, we used to put the proper address and the PIN number. If you write the PIN number wrongly, what will happen? Let's say you have dropped your letter in a letter box, then what will happen? Let's say it will be going to GPO of Calcutta. And then what will happen? If the PIN number has not been written properly, it will be going to the wrong address. Wrong address. Then what will it mean? I have an intention to put this letter to a correct places. But since it has not been designed properly, address has not been given properly, then what will happen that it will be going to a wrong person's address. Similarly, any of that, in my email ID, instead of some of the word, some of the letters, if you put the IL, okay, then it will be going, instead of Indian some domain, it will be going similarly to the Israel. Or if you have a phone number, if you write during the ringing any of the number wrong, then what will happen? This will be having a miss call to the others. Okay, so that incident will be occur. It will miss the target. Okay, so we usually don't want that it will be miss the target. Then whatever we have shown here, what happened? It is if the nanoparticles partially have the efficacy by efficiency or is designed wrongly, then instead of reaching to a particular organ which is under threat or under disease, instead of reaching to a particular organ, then what it will be happening, that it will be going to a wrong organ, okay, where it may happen that, okay, instead of going to, let's say, liver disease are there, nanoparticles supposed to be translocated, or it is to be, will be reaching to the liver, it will go to the another organ, okay. So that thing will be there. So why, whenever we will be designing some nanoparticles, it should be designed properly. But truly speaking is that most of the cases it fails the target, okay, it misses the target. Some example can be given in such a way that, let's say, drug delivery system. You see that some cartoon are there, okay, some cartoon customized delivery systems are there, which is filled with the drug and targeted cell is the, okay. Then if you see that, let's say you have a chemotherapy drugs or nanocapsules which have certain efficiency to the kill to the cancer cells, okay, to kill the cancer cells, then what will happen, okay, if it is not properly attacking to the cancer cell, then what will happen, it will be attacking to a normal cells. So at that cases, so normal cells will be under threat, okay, normal cells will be under threat. This all are the story or example are that why we need to make the nanoparticles, or why we need to design a nanoparticle in such a way that instead of attacking to the normal cells, it should attack to the infected cells. So that all are the idea of this, okay. Another thing, that this is the story of the nanocapsules or nanoparticles or nanomedicine, whatever we will be making. What is the intention? First we have to think it, first parameter we have to think it, why we will be making this, fine, okay. Then let's say if you have a just a minute or another, I have to probably check another one. I want to show something else which is not showing here. Some other things I wanted to show here, okay. Now see that is whatever I have shown in the previous slides, that thing much deeperly we can think it. So in these cases, first I have told that there will be a threat of nanoparticles, that it will be reaching to the organs, fine. Then what it will be going, so it will be translocate and then it will cross the barrier of blood or endothelial cells, then it will be going, then there will be cells. You most of you know about the cells, okay. Now if we understand the chemistry of the nanoparticles, then what will happen, whenever it will cross the barriers of the cells, where it will be reaching to the cell membrane, okay, it will be reaching to the cell membrane. And there are lot of mechanisms are there where, let's say, food, medicines, nanoparticles will be going inside the cytoplasm. Let's say catherine mediated will be there, caveolin mediated will be there, pinocytosis will be there, or other mixed pathway will be there. Most of the cases it has been found that, okay, since nanoparticles have the charges, they will have the electronic environment, they always will be going inside the cell followed by the mixed environment, a mixed pathway. Let's say they will be going inside the cell in the mixed pathway, okay, they will be going in the mixed pathway, they have reached, okay. So what about these will be forming inside this, going, they will be forming and they will be coming out, the nanoparticles will be coming out and will be there in the cytoplasm. Whether that is the destination to reach cytoplasm? No, that is not only the destination. Let's say if you someone are there, let's say in Jadavpur, okay, Jadavpur, it's close to railway station also there, and if you move little bit to the, let's say, the Bhavanipur or Goria somewhere, you will get the metro also, and you have the option of auto also, and you have option of taking the buses also, and you can take the Ola cycles, let's say Ola bike, so many things will be there. The environment, whatever you will be facing to reach to your destination, let's say Dakshineswar, okay? If you go by train, you will be facing the environment differently. If you go by the auto, or if you go by the Ola, let's say cycle or Ola bike. So inside the cells, similarly, whenever a nanoparticles will be going, they will have the different environmental threats. Inside the cytoplasm, there will be Golgi body, there will be, let's say, genetic component, there will be some others. Lot of chemical environment will be there. Okay? And let's say mitochondria also will be there. If your nanoparticles directly attack to the mitochondria, if they accelerate the property of the mitochondria, that is fine. If they reduce the mitochondrial membrane potentials, they hamper, then what will happen? No energy will be producing from the mitochondria. Instead of that, if they destroy the mitochondria, then what will happen? Cell will kill. Okay, cell will be destroyed. The normal cell in the broad sense, normal cellular activity will be disturbed. So why we want that if these phenomena occur for the infected cells, then it is very easy to kill the infected cells. But after nanoparticles going inside these normal cells, if they disturb any of the biochemical activities and cellular reactions, whatever needed to survive, then what will happen? Normal cells also will be dying. So why this type of phenomena is called the toxic. So nanoparticles is toxic. So this is one type of toxicity in nature. Okay. So nanoparticles will be toxic in nature. So we usually don't want that. Nanoparticles will have the activity, and it should not produce, it should not degrade in such a way that the degradation product should not be produced in such a way it will not react with the any other components, biological fluids of the cells, or the fluids flow through the bloodstream. Okay, that will be there. So toxicity can be in the different, and different stage it can show this toxicity. Toxicity of the nanoparticles will be working against the, let's say, immunity. Okay, whatever the type of immunity is there. Let's say cytokine, chemokine, whatever will be there. If they react and if they decrease the level or increase the level, toxicity will be considered in that angle. Okay, in the molecular level. Fine. So we have to keep in mind all these things. Now you see that, let's say you have a nanoparticles. Now you wanted to deliver the drugs. Okay, I will be coming here, deliver the drugs. I will be going some other slides and I will be telling about the delivery of drugs. Let me take out the slides where I will be telling the delivery of drugs, where we need to load these nanoparticles inside the medicines inside let's say inside the capsules in such a way that, okay, how we'll be deciding a nanoparticles, okay, which will be loading inside these capsules. Okay, then again I will be telling. let's say figure how the nanoparticles is look like. If I have a good images, then I'll be showing you, let's say then I'll be telling something, let's say how it look like nanoparticles. Okay, I'm just coming. Okay, this will be, it's any type. Let's say one example I have given here. Okay, then I will be coming to these slides later. Okay, so nanoparticles will be, let's say, spherical, triangular, tube, it can be hollow, it can be porous in nature, any whatever the structure we can imagine from our mind, that any type of can be there. They can be dissimilar in size, but we have to keep in mind that if we use the nanoparticles, let's say polymer and other things, okay, that nanoparticle size supposed to be smaller than the blood cells or other components of the blood, so that after the interactions of, let's say, continuous interactions will be there between with the blood cells, okay, there should not be any side effect. Okay, so this usually nanoparticles as sphericals are better to use for the delivery of application. You see that these nanoparticles are, you see, so nicely made around, let's say, 200 nanometers, 300 nanometers. They are very much spherical in nature. Why need the spherical in nature of the nanoparticles? I will be telling you again. So what I wanted to tell that, okay, whenever you are taking a, let's say, drug molecules, how it will be there inside these nanoparticles. Those who were asking me how to making the formulations, okay. Let's say nanoparticles is spherical in nature, then how you'll be loading the drugs? Whether you can load the drugs in nanoparticles, if the drug molecules need to be loaded. Anyone have any idea or have experience to load the drugs molecules in nanoparticles? Anyone can respond? Do anyone can respond how the drugs can be loaded inside the nanoparticles? Then I will be telling in deeper. Anyone? Whether anyone have any experience of loading the drug molecules inside these nanoparticles? Anyone?
Sir, maybe modifying the nanoparticles with certain ligands and
Okay,
then
this is
attaching the
one
drug
options. Okay, very
onto
good.
that.
Anyone? Anything else can have?
Sir, I think any particle can be attached with the nanoparticle through their functional group.
Functional group. Okay, it's similar type that we have to have a ligand. You will be attaching on the surface of the nanoparticles, and then you can attach. Fine, fine. Next.
In one lecture, we had heard about aptamers and dendrimers, all that.
Dendrimers will have a certain structure. It is like, let's say, tree are there, a lot of branches are there. Okay, it will be there. Fine. Okay.
Okay, sir.
Anyone, anything else idea are there? Both of your cases, what you are telling is that you wanted to take the drugs molecules, okay, on the surface of the nanoparticles. Am I correct?
Yes, sir. Yes.
Surface of the nanoparticles. Let's say I will be telling you, let's say your home place in Jadavpur. Okay, fine. You are there in let's say Sialda stations. You have two options. You can go by metro or you can go by any of the local train. You will be dropping down in the Jadavpur railway station. Fine. Okay. What you will be facing? Whenever you are in metro, it will be less crowded. nobody will be from the outside of the train can be attack you. Let's say attack means let's say bee or any insect. You forget about any enemies, bees. So you will be there in a confined spaces, which is quite safe. Okay, but if you go by local train, door will be open. Lot of, let's say if it is winter, then lot of winds will be giving you threat with cold air, and there is a chances you may attack by the cold, and lot of virus cold will be there. Okay, from this I'll be telling is that why we usually not prefer, okay, in the first attempt your drug will be on the surface of the capsules. Why? Example I can give you. Let's say you are inside a room, let's say present inside the room, you are completely detached from the threat of the outer world, so you are quite safe. If your drug molecules are there on the surface of the capsules, then what will happen? Your drug molecules is a chemical. We do not know actually how many millions or trillions of chemical reactions occur inside this body. Very few we know. Then there is always a chances, okay, whatever the drug molecules are there on the surface of your capsules, that can react. Okay, so before reaching to the target, okay, what will happen? These nanoparticles will be in the under threads, and the drugs will be reacting with the endothelial cells or other biochemical components, and whenever the nanoparticles will be reaching to the target, the efficiency of curing the drug molecules to a particular disease will be reduced. Dr. Namrata, have you got this point, what I am telling, and Dr. OP?
Yes, sir.
Okay, so why we
maybe
first
some
don't
non-specific interactions.
non-specific interactions chances are much more with respect to if you take the drugs molecules inside the capsules. Okay, got this point?
Sir,
Now,
I have one question.
uh-huh.
Suppose I have attached the drug to the nanoparticle, then how can I know that how much percent of drug is attached with the nanoparticle?
That also the procedure is there. Okay, this I'm noting down the questions. Okay, how much percent, and I will be answering you timely. Okay, so you see that I'll be coming back to these slides, and before that I will be telling why the drug molecules required to load it. Okay, can you see these slides, whatever I am showing?
Yes, sir.
You see that, let's say many of we have the experience whenever we eat something, okay, let's say some medicines, okay, stain with yellow color or something red color. We found that after certain hour, that similar color urine generated and they go outside from our body within few hours. So if you take the medicine in free, then what will happen? There are three chances are there. It will circulate few times and everything will be going out from the body. Okay, if it is not specific to the target. Then what will happen? And what will happen if the drugs, let's say photosensitive in nature, which drug example is anti-cancer drug, chemotherapy drugs, okay? So they are very much photosensitive in nature. Then what will happen? If you take this on the surface of the capsules, they are not inside this capsule, then what will happen? The threat will be light. So they will interact with the light, because light can penetrate up to, let's say, 2 mm of the body, okay? And drugs molecules also, our skin is not 2 mm, okay, thickness is less than that. Then what will happen? Drug molecules will be interact of the light, okay, and after the interactions the drug molecule will be destroyed. Okay, fine. So what happened most of the cases when the patient are under the treatment with the fluorescent drug, they are advised not to come out from the room, or whenever they will be staying inside the room, the light will not be sufficiently brighter with the lights. Okay, so then they will be interacting with the light, and if the drugs are free, they will be coming out through the urinary tracts after a certain period of time. And if you take the nanoparticles loaded with the drugs with the nanocapsules, which will be having, okay, I'm in a meeting, okay, I will call you back, okay, I'm in a meeting, I will call you back, huh? So then what will happen, okay, they will be saving all the drugs molecules will be safe inside the capsules. Then another threat I told, though they will be safe whenever they will be going inside the bloodstream. Then they also will be safe, the drug molecules, when they will be going inside the cell also, okay, crossing the cell membrane and reaching to many of the parts of this, many of the components of the cells, okay, and they, if it is target to the nucleus, they will be going. Then what is coming? You are going by a train from the Sialda station, let's say to Bhawanipur. You are quite safe because you are an important person. Similarly, drug molecules here is very important to reach to the target. Okay, so they will be quite safe. So if you wanted to go to reach safely, you can reach to the Bhawanipur and can go to the home without any environmental effect. So we are checking environmental effects here. We are against the environmental effect. This will not work against the cell. Now thing is that what I wanted to tell is that you see that, let's say anyone, again one question is there. So what do you want? Your capsule will be solid or porous or hollow? Anyone can tell how you want your capsules? Solid, porous, hollow, mesoporous in size? Whether you can tell, anyone have experience with working with this type of materials environment? Anyone can tell? Do anyone have experience to work with the capsules which is functionalized with, let's say, poured, hollow? Okay, we discuss about the, let's say, functionalization of capsules. Anyone? Whether anyone have experience? Whether anyone can respond? Excuse me.
No, sir. No, sir. No experience.
Okay, let's say many of you do not have the experience with working with the porous materials, but we have a experience to enter in our house. Okay, in the house we'll have a window and we have a door. Fine. So if we stay outside the room in the winter, we'll be cold, feeling cold. If we enter outside the door, outside the house, if you have a house, a particular room assigned to me, there is a door where I can enter. Okay, am I right? Everyone, we have a specified room at home, maintain the privacy, okay, in the classroom, anyone. Am I correct? Is there most of the cases? Or if you share the room, there will be sizes of the room and sizes of window also, so that we can inside the room. We can enter inside this room. Now check this case study. What about the, let's say, ibuprofen, whatever is called, it is an anti-inflammatory drugs used for many of the inflammation purpose, anti-inflammation purpose. It has a size of 1 nanometer. If you see the gentamicin, okay, here whatever I have shown, gentamicin have the 0.9 nanometers in diameter. If you see araldronate, 0.61 nanometer. erythromycin, these are the antibiotic, amoxicillin 1.2 to 1.1 nanometer in size. So whatever the drugs molecules you will be loading, they will have a size. Okay, they will have size. And if you see that brovine, serum, albumin, it is used frequently for various purposes, immunotherapy purposes. It has size of 10 nanometer. So now you tell that if you would like to load this type of drugs molecules, what will be the pore size, okay, of the capsules? Or if my height is, let's say, 5 feet and 6 feet, then we need a door to enter inside this room bigger than me. Am I correct? Am I correct? Dr. Kaushik?
Sir, yes, yes.
Yes. So if my height is 6 feet, then I have to have a door in such a way that I can enter inside this room. Am I correct?
Yes.
Yes. Perfectly. Similar way, whatever the drugs molecules will be taking, if you wanted to load it inside the porous network structure, then whatever someone was telling that Dr. Orunima, whatever is telling that we have learned about the loading or delivery of drugs molecules with dendrimer. Okay, so what we are considering in these slides is that we have to have the different drug molecules with the different size, okay, which will be having a size. And if we wanted to load inside these capsules, the diameter and pore size of the capsules will be in such a way that these drugs molecule can enter. Okay, drugs molecule can enter. Am I correct? Okay, Dr. Kaushik?
Yes, sir.
Okay. Now let's say you are going 218 bus. Okay, 218. It's go from, let's say, Baripur to let's say, I do not know, still it is going to Dharmatala or not. It will be going. So
Yes, sir.
let's say this, it's go?
Yes, sir. Yes, sir.
Yes, it's
The
go.
buzzer is still on, and from
Still on.
Narendra to
So I will be telling one experience. Okay, similar way, let's say train. If it is giving jerking, lot of jerking is giving, then what will happen? There is a chances of falling down. Unwantedly we will be going out. Okay, from the bus, from the train. So it should be, there will be closing of door. So what we do that after entering in the room, for our purposes, for our privacy, to protect us from the threat or environment, we close the door. But what will happen that very limited cases, we close the window because there should be a circulation of air, not the protection. Similarly, we need the porous network structure to revive and for the survival purpose, or some continuous, let's say some drug molecules always should be there in the liquid medium, otherwise there will be degradation will be there. So I have given the example that in the room, whenever I will be there as a drug molecules, that is a door will be there through which I will be entering, and there will be a window will be there which will be continuously supplying the, or it will have the touch with the cellular environment for the survival of any genetical component if you use the genetical component for the medicine. So what is coming that? There is a door, there will be window. Now question is that you are inside the door, or let's say outside the door was closed, you open the door. Whenever you push the door, what happened? Do you have any experience of that, or have you noticed? Whenever you open the door of a room, what experience you feel in terms of the ambience? What experience you feel? Anyone? What do you feel? You feel that whenever you open the door and whenever you push the door, some of the air go out through the window. Am I correct?
Yes, yes,
Yes,
sir.
sir.
Yes.
Mhm.
We
Yes, sir.
have an experience of homeopathy medicines bottle. Okay. If you fill it with water and with some percentage, and then if we turn it down, means let's say this is a bottle is there. Okay. Let's say it's similar to the homeopathy bottle. Okay. And if you turn it out, then what we see that that liquid or the medicine what is there inside, that will not go out. Am I correct? It will not go out. Let's say we have experience, we have taken a pen, okay, head of the pen, we put it water. Sometimes we have done in school, put in the childhood time, put water, but we see that the water never come out. Okay. So it is a liquid medium will be there where the drug molecules will be there and it will feel will be there. That can be, and then if you dry it, then what will happen? Drug molecule itself will be there. Okay, inside these pores or in the closed vessels. Okay, like us, we are in the door. Okay, since we are alive, we can come out whenever the requirement. But whenever the drug molecules will be there, or if it is not in contact with the liquid medium, then what will happen? It will not come out. Okay, whether it will come out, it will not come out because it's in a life. Yeah, it will have some influence to come out. Okay, it should have some influence to come out, otherwise will not. Why I have given an example of homeopathy medicine bottle when something is there, because the air pressure from the below, environmental pressure, if equivalent the pressure of whatever generated inside this bottle, if they are same, then if the bottle containing something, then that will not come out. Okay, similar way, whenever you are loading the drug molecules inside a porous material, see, you see that how many parameters you have to keep in mind. When, let's say, gentamicin, amoxicillin or doxorubicin, any are there, they are inside the pores. So not only loading is important, something influence will be there which will be coming out from the capsules. Okay, otherwise there is no meaning of loading. I have successfully done the loading of the drugs inside this capsule, it will not coming out. Okay, so you have to keep in mind, lot of questions you will be getting for working with these nanoparticles and the loading of the drugs. So where I am is that, let's say loading only not important where you are loading, what is the size of the capsules, what is their pore size, what is the size of the drug molecules, and in which state they will be there, whether they will be in the liquid medium, they will be dry, they will be whatever the condition. So otherwise what happened, okay, if the sufficient parameters has not been considered, then what will happen? The drug molecules whatever loaded, they will not be delivered. Okay, or now there was a question is that how much amounts of drugs molecules will be loading. Okay, let's see in the next slides. Okay, that will be depend on few parameters. Okay, now from the surface we come inside these capsules. Okay, inside these capsules. So one beautiful example I will be giving you, that you all have that experience from the Calcutta. Okay, those who are in Calcutta and city. Can you remember this image? Anyone? Or do you enjoy with this image? Everyone, those who are the female faculties and women faculties or girls are there. Okay, or boys are also fascinating. Can you see this image, whatever I am showing?
Yes,
Yes,
sir.
sir.
Do you enjoy with this?
Yes, sir. Yes, sir.
You enjoy with
Yes.
this? Whenever you go in
Very
front
much.
of the shopping complex, okay, or somewhere else, we enjoy. Why not we enjoy? So this is the Golgappa, known as it is famous somehow. But you see that there is a mouth of the Golgappa. It's fine. See this mouth of the Golgappa, let's say Golgappa, it's a brittle in nature, make a void space inside already made. The void space not only the important. Void space there, it will be like a football. Okay, but for a football, if the air is not there inside this football, then there is no meaning of the football. Similarly, Golgappa is there, it is closed, but this no meaning. Where the interesting test come? Can anyone tell? I am not too much experienced because anyone, those who liked. Why?
Sir, the stuffing which is put inside the
Stuffing you need to inside. Okay. So stuffing, what is the stuffing? Anyone tell if you know?
The water also.
Water also is there.
also, right?
Okay.
Tamarind water.
Turmeric water there, lemon water there. Then stuffing and potato are there. Those who like a little bit chili, they want. Okay, the mix, na. So this is always a purpose of doing this, not only the taste. Similarly, whenever we make these capsules, I'll be telling this story because this is a very cartoon. Many places I show because we enjoy this when we become satisfied. Okay, but stuffing we need to put it. This potato, all other things because it's required to get the taste. So if you assume that your Golgappa is a capsules, then nanocapsules hollow. Not only the criteria, you have to make a pore where you will be putting the the stuffing along with the water. If you do not take water with lemon, then if you take only the potatoes or in a mixture and if you eat it, whether you will get the taste? Whether you will get taste?
It will be incomplete, sir.
It will be incomplete because your potato will be there inside this water, which is also tasty, na? Okay, then it will get taste. Similarly, this should come out. It will burst whenever it will going inside the mouth. You will press it and it will burst. Okay, suddenly whenever it will coming out, then you feel the real taste. Okay, that the one example I have given. Okay, or it's making to you to feel that why we need to make the pores or certain structure of the nanocapsules because we have a purpose. Now you see that. Then I will be coming. This has been filed the patent. So you see the Golgappa is taking, let's say, okay, and we have made a capsules with the Golgappa also that we will have a mouth. Okay, you will have a mouth. You can put it. So example is very much clear, and then I will be going to the slides where I was there. Now, how much the amount of your ingredients you will be putting inside these capsules or the pores that inside these capsules, that will be depending on the pore diameter. Why pore diameter is important? Because your drugs molecules will be having different size. And the pore diameter you need different to load the drug molecules inside these pores. Now, how much drug molecules? Some question was there. Okay, how much drug molecules will be loaded? How much drug molecules will be loaded? So that will be there. How much volume are there inside this? We take the Golgappa. We need to put something. How much we want? How much liquid will be there? That will be depending on the how much volume are there. Now let's say if you come out with that a conventional things, they are not only the physical interactions is important. I want that the drug molecules in any circumstances will not be coming out from the capsules through the drawer. Then what we need to do? This is a question for you all. Let's say you don't want that whatever loaded inside this capsule is supposed not to come out. Then what we need to do?
So close the window.
Close the window, fine. It is a permanently will be closing or for a temporary purpose?
For temporary purposes, so that when it reaches the target cell, then we can open the window and slowly the drug can be released.
Very nice question and nice answer. But then what is coming that whenever we need that time it will be opening. Fine, that will be opening. So whenever we go inside this room, it is a night time, we lock the door. And whenever it's morning, we have the influence that we have to come out from the door, then we unlock. So we come out. Fine, okay. It is not means that the door, if a room have the multiple doors, it is not means that the door which is through which I enter, I have to come out through this. If I feel in the morning time, the room is attached with a balcony in the opposite door, then I feel, okay, morning. It's a morning, sunrise. I wanted to see sunrise. Okay. And that is lot of gardens are there. Though we come out in the opposite. Usually that is the way. So what happened? Then how you will be designing that whenever you need to come out from the room at that particular time also will be coming out. How you will be designing? How? What is your influence? The example I have given you.
With the timer.
I have given an example. You enter through a door, you locked it, and then you thought that it is now morning. You have to go to balcony. There is a, let's say, lot of flowers, which attract you to come out. It's not some attraction. Interaction are there. Fine. And what interaction in night time was there? Let's say outside is very cold. You don't want it to go out. Okay. So what is there? In terms of the chemistry point of view, so there will be capsules designed in such a way that the drug molecules will not only physically will be there. There are some chemical interactions will be there. Let's say electrostatic forces of interaction will be there, which will be allowing the drug molecules to have a interactions like a magnet to iron. It's a, if your magnet is made through the electricity, let's say U type. Okay, you are taking iron U type, you are giving it is covered with a coil, okay, and then you are allowing the electric field and it will coming magnet, and that magnet will be attracting some iron. Now we disconnect with the magnet, then what will happen? There will not be electric field, magnetic property will be lost, and let's say iron will be detached. Similarly, you have to think that during the design of the capsules, we have to make in such a way that some interactions will be always working with the capsule's property and the property of the medicines or whatever the molecules, protein, peptide, whatever you wanted to use as a medicine, DNA, RNA, whatever is in here. We something don't know it has the medicinal property or not, what that can be used as a medicine. Okay. So that interaction forces always has to create with the capsules so that the drugs molecules will be attached inside the capsules. So what need to do? We need to functionalize. Then the question is coming. We need to functionalize, okay, functionalize with the proper functional groups the capsules. Now where will be functionalized? On the pores surface, pore mouth, or inside the capsules. According to your requirement, you have to do it. Okay, how you want. So you have to keep in mind that you want what you want. Now let's say by this way, pore volume, pore shape, pore diameter, pore surface area, in the surface area places of drug molecules will be attached. If pore shape are there, let's say some drug molecules are cylindrical, some is spherical, some have like a small one. The pore shape will be in such a way that it will be fitted inside this pore. So what the pores volume will be doing? Pore volume will be telling you how much pore volume or the cavity volume will be telling you how much the drug molecules will be loaded. How they will be attracting? They will be attracting through a electrostatic forces of interaction. First, some of you answered that we will be loading the drug molecules on the surface. Why? Other things what will be happening? Let's say if we have something on our skin, then what will happen? It will be going out. So if the drug molecules are on the skin of the nanoparticles, then they will be released fast. Okay, let's say within 2 hours. there will be release. Let's say here it is saying 75% drug molecules will be releasing, which is called the burst effect. So they will be following a kinetics. Those who are from the chemistry background or life science background, everybody you know the kinetics. Okay, kinetics of release, kinetics of reaction, some other thing. So there will be kinetics. A very simple kinetics will be there to release very fast. And second cases will be there. There can be follow the exponential rule. Well, it will be something different. And some cases will be there with time. With increasing the time, the continuous release of drugs will be there in the straight line, whatever showing in the figure C. And other cases will be there whether whatever example you have given, that whenever drugs we need to release, that time will be released. Then what can be the stimuli? Can anyone tell what can be the stimuli so that whenever we can release the drug molecules according to our requirement? Anyone can tell? What could be the influence?
So the change in pH?
Changing pH is a very good option. Anything else? Anything else?
Mechanical forces?
What type of mechanical forces?
Sir, maybe temperature can be one.
Temperature can be very good. Temperature can be. Anything else? Well, very good. Huh? It means that you all know many things. Many of you, yes, it will help me actually. If I know that, then I can show you so many examples. Okay. Anyone? Anything else? Okay, it's very good. You have told me that temperature or other parameter can also be there. Now you see that. So the stimuli can be magnetic field, that can be temperature, that can be pH, that can be magnetic field, that can be anything else. Electric field can also be there. Okay. So you little bit try to understand. Okay, if someone you don't have the experience with working this type of system, let's say you see the D plots in the right side below. You see that first step you are using the magnetic field, you see the stimuli. Then once you will be applying the magnetic field, then what will happen? With the magnetic field, there will be magnetostriction and interactions with the drug molecules, they will be coming out. Then you stop the magnetic field. Then what will happen? There will not be any interaction. Okay, it will be stopped. Again, you increase the magnetic field, then second step will be there. Stop it, it will be fixed. Again, you do it similar way. The step by step, time to time, periodical enhancement of magnetic fields and off and on mode of the systems will be helping you to release the drugs from the capsules whenever you are required. Am I correct? Let's say whenever some influence is there, you will be coming out from the room and you will be interacting with the environment. Whenever my mummy will be calling, then I will be coming to the dining hall and we'll eat. Fine. Mommy told that you come for breakfast, I will be taking light. Mommy told pre-lunch, you come. Means I have taken something in breakfast, then pre-lunch something, intermediate, some foods. So the amount is that I have taken some amount, let's say 100 grams of breakfast, then another 100 grams pre-lunch. Total how much I have taken? 200 grams. So second step will be 100 grams for 100 grams. So total intake of inhaling the foods, taking engulf the food is 200 grams. Similar way, opposite sense, you have a glass, okay, or like a bottle this, one time you turn it down, some amount will be going, take it, it will stop there, and again you take it. So in consecutive way, if you do off and on, then total you will be reaching that after certain period of time, the drugs molecules will be going out according to your requirement. Okay, I will be giving one example. Very nice example are there. Okay, where it use actually, what is the use of that? Fine. Let's say temperature are there. Okay. Temperature. Do anyone have suffer from malaria at any time? Do anyone suffer from malaria at any time?
Yes, sir.
Yes, sir. What you feel that time? What is your experience?
It was very high fever at that time with the
Yes.
shivering at
And
Calcutta
then,
and
and then,
shivering.
and then,
And
what
then
is the periodicity of the fever you feel?
it occur at certain time interval.
Certain time interval. Then there will be a periodic. Let's say 6 hours, 12 hours, 24 hours, 48 hours, 74 hours. Am I correct? Okay. Many of we have, okay, in Calcutta suffer from malaria or in tropical country. What happened actually? I'll be telling you that. So malaria is a parasitic disease. Okay. In the life cycle, there will be lot of stages. It will be merozoite, then let's say ring formation will be there, early trophozoite state, late trophozoite state, okay, early schizoinate, okay, it will be there. Then what will happen? Whenever parasites attack the blood cells, okay, red blood cells, the spore will be generated, and whenever it will be bursting or some stages, again it will be infected from one blood cell to another, and it can reach to the brain also. So real image we have taken in the lab, okay, in our lab, we found that there is a stage. So we have tried to correlate this. So what will happen? Now let's say the common medicine used for the malaria treatment is the chloroquine. Some artemisinin are there, artemisinin, okay, dihydroartemisinin, which is got the Nobel Prize, that also is there. Okay, that is there. We have used also, that is, let's say, temperaturely, that's very much unstable. So with this, you see that with the life cycles, there will be a change in temperature, let's say with 24 hours, in 40 hours or 48 hours. Fine. So whenever you detect that at what position the temperature will be increased. Okay. And if you think that if I am inside this room is very hot, then what will happen? I will come out. Okay, I will come out from the room, and I'll be going to the place where the temperature will be less. So what we have done, or one example you take. So you have a porous capsules, you have a chloroquine, you can load it inside this, till all the pores are, okay, filled. Capsules, chloroquine, all the capsules are filled with the chloroquine. Then there is a lot of blood cells. Many of the blood cells are, okay, infected by the P. falciparum, okay, parasite, let's say, and then lot of spores generated, your body temperature has been increased. And now you are thinking that you will be using temperature as a influencing parameters, where the nanocapsules loaded with the drug molecules will be coming in contact to this bloodstream, body temperature is there. Then the loadings of the drugs, whatever are there, they will be coming out. If you take little bit more advanced form, if you think that these nanocapsules will be going inside the blood cells and they will be interacting with the parasites, and in the blood cells also the temperature also will be, let's say, 40 to 43, let's say 102 degrees centigrade temperature. At that 102 degrees centigrade temperature, whenever it will be influenced by the temperature, the chloroquine will be coming out, and chloroquine will be interacted with the parasites and it will be killing. Then what will happen? Whatever the parasite growth were there, they attack to the blood cells and they kill, and this blood cell will be cleaning. The infected blood cell will be killed. Let's say few more are there. Parasite are there. So few more the parasites, those who are there, there is a possibility your capsules will be releasing continuously chloroquine and they will be interacting with that. But if your capsules is designed in such a way that when temperature decrease inside this body, the way we close the door, okay, and we are inside in the night time from the room, then what will happen? There is, as a drug molecules I will not coming out. Similarly, again, whenever the parasites will be growing, okay, and temperature will be increased, then what will happen? The drug molecules will be coming out and will be interact. The same story I am telling here, okay, in the stimuli cases, if step by step temperature increase, whenever the requirements, the drug molecules will be coming out here and it will be curing the parasite. Any question is there from this? How the mechanism work? Anyone? Anyone? Those who?
No, sir.
This question is there. Similar cases, I will be showing this plot, whatever we have checked that. You see that before these cases, we have already filed the patents and something else. If you see this, the capsules are there, which have a lot of pores. Temperature increase, capsule's mouth will be open. Let's say one more example in the middle of this I will be showing. So one capsules is there, okay. This capsules is very much temperature sensitive, okay. It made up of polymers or something, which is a property have responding with the temperature. When the temperature increase, let's say it will be unfold, and whenever temperature will be decreased, it will be again squeeze and it will be fold. See, if capsules is looking like this, when temperature is very high, the mouth will be open, unfold. Let's say your dendrimer, somebody was telling about the dendrimer. Then, okay, whatever, it's like a, on leaves are there, if you touch it, leaves are squeezed, leaves can be squeezed. Huh? Okay, those who are from the botany, they, you know better what is the name of the scientific name. I do not know. So whenever mouth will be open, the drug molecules will be going, temperature will be down, they will be engulfed or be loaded like this images, and whenever again, let's say temperature will be increasing, they will be coming out. So this, if the temperature LCST is lowest critical solution temperature, lowest critical solution temperature, T value up and down, loading and unloading will be there. These parameters, usually this phenomena actually used for temperature, for the temperature restoration cases. Now thing is that, okay, so what is coming here? So if we take time temperature clock, this is like a time temperature clock. When the temperature will be different in the systems, okay, then they will be releasing different quantities of the drug molecules, and we have very much successfully have been shown the proof of concept that using this time temperature and time temperature clock, the polymer capsules can be used or can be synthesized for the purpose of loading and releasing of the drugs, which is influenced by the temperature. Fine. So one more example, what is the time is that you see the cartoon here, okay, where we have shown that savings countless lives in nanomedicine for malaria. The lizard can engulf the mosquito, but if sufficient lizard are not there, mosquito can bite at any time. Your body temperature can be influenced by many things, okay, and that cases you use this technology and can be cure the malaria or the something else. This is influenced by the temperature. One more example can be given is that it has been somewhere else. So if pH creating mechanisms are there, with change in the pH also, you can load and release the drug molecules. So it change in, this is there, okay. If you see that, we change in, where I forgot to tell you where the pH change occur inside this. If you see that, okay, these images, it has mentioned that at each and every cases inside the cells, all the pH of the bloods is almost 6.9, but if you see that there is a pH, let's say liposome pH, late endosome, okay, some cases, if you see that pH are different inside this, and whatever pH which measure for the blood, this is an overall. Okay. Similar things occur for the cancer cells. Quickly, I will be telling you when in cases of cancer treatment, cancer cells pH can be higher or lower depending on the type of cancer and whatever the functional modification occur on the surface of the cancer cells. If you can design the capsules in a particular way, so based on the pH verification variation, you can use this pH sensitive nanomedicine and drug delivery. Another cases, if nothing in influencing, what will happen? So let's say you have a drug molecules, okay, inside these capsules. Capsules have the property of degradation. You see that degradation. If capsules are there inside this, the drug molecules can go by the diffusion, or drug molecules can go by the degradation after the degradation. So if there is a layer by layer degradation, surface degradation or bulk degradation, okay, based on the degradation type of polymer particles, how fast they are degrading or how slow they are degrading, based on that your delivery or dose of the drugs will be there. Now, I have shown in some images that capsules are uniform in size, because we need the capsules uniform in size, because if we know that per capsules how much drug molecules can take or how much drug molecules can be loaded inside this capsule, based on that we can find out the doses of drugs. Someone question was there, okay, how you will come to know how much drug molecules are loaded inside this capsule? Am I correct? Some question was like this. Am I correct? Some question was there from someone, how much drug molecules can be loaded inside this capsule? Is anyone is there? Someone who was asking how much drug molecule can be loaded inside this capsule? Is there someone who was asking this question? Excuse me, someone was asking. Who was asking how much drug molecules can be loaded?
Yes, sir, me. It's me.
Okay. So now you see that, let's say you have a sponge. Fine. Okay. And now we have put it inside the, let's say, what is this? It's called this. Let's say in the salt water. Okay, salt water. And now after dipping inside the salt water, you have taken out and you have dried the sponge. Then after evaporating all the moisture, what changes will be there of the sponge? Dr. OP?
It will dry.
If you dry, there is a salt water or sugar water. You have taken the sponge inside this water and you have taken out this sponge and you have dried it. What changes will be there in the sponges?
So the water will evaporate, but the salt and sugar particles may remain inside the sponge.
There will be exactly this salt and sugar molecules will be there inside the sponge, inside the pores of a sponge.
And water will evaporate.
And then what will happen? If you know the whatever the amount of the sponge in terms of the weight was there, the initial amount, weight and final weight, if you subtract it, then what will happen? You will come to know
how much amount of drug has been there.
Loaded.
Fine.
Do anyone? It's a bulk cases. Let's say how you come to know a capsule, say, let's say nanoparticles, you have only these doses usually use 1 microgram. Okay. In 1 microgram capsules, how you will come to know it has been drug has been loaded or not? If any have an idea, just I will be telling them. How will come to know? I will come to know. Anyone? Dr. Orunima.
Sir, can you repeat the question, please?
How will come to know that drugs has been loaded or not?
Yes. How much amount are we taking on the very first place? We can go for a milligram of doses and then gradually count it on the basis of micro or nano.
Measuring the weight, no? Okay.
Uh,
But whenever you will be using a doses that is few nanograms, okay, how will come to know whether it is loaded? Qualitatively, not quantitatively, let's say qualitatively. Let's say
Maybe by spectrophotometry changes.
so is that, let's say, so many methods are there. Chemical methods are there. Physical methods are there. Physical method one is weight, if it is a bulk size. Chemical method, what will be that? Suddenly, if you do the FTIR, let's say, finding out the functional group property of the total system, then you can, let's say some drug molecules is containing some amino acids or COOH, then what will happen? If you do something spectroscopy study, then it will be giving the indications that there will be amine group or COOH. Am I correct? If
Yes,
you do FTIR, then it will be saying you that some functional groups are there inside this, okay, and it will be there. So similar way, FTIR, Fourier transform, let's say infrared spectroscopy, UV visible spectroscopy, if it is responsible, drugs is UV visible responsible. If your drug molecules are fluorescent in nature, then you do the fluorescence spectroscopy study. It will give some spectra, okay, fluorescence spectra. These are the quantitative measurement. In terms of visual measurement, you take your capsules, if you think is loaded, if drugs is fluorescence, you take under the fluorescence microscope so that fluorescence light will be illuminated. If you see the something is there, I will be showing you some example. The fluorescence image can be given where the capsules will be illuminating the fluorescence spectroscopy images. Okay, I will be showing you somewhere. Lot of things are there. Another thing is that to measure the
Sir, I wanted to just ask one thing. If the drug has been loaded on the nanoparticle, so there may be change in the size or the shape of the nanoparticle also, which maybe can be monitored through tunneling electron microscopy or scanning electron microscopy.
So thing is that also can be there, okay, that also can be there. But whenever you will be taking a capsules inside the solvent, there if it is expanding, sizes can be changed, that also visual explanation will be giving. Or if it is on the surface layer can be visible in different way, that can be checked with the control of your sample, okay. So that also one type of observation, that is also one type of options, okay. If you do not know that it is degrading and expanding, size is changing, that cases what is happened, that if you have drugs with the certain properties, and that cases you will be understanding that, okay, that's cases. I will be showing some example. You see, you will be where we have loaded the DNA molecules. Okay. So if you see that same, I am coming with this because this is a very nice example. If you see that, okay. So in nanocapsules we have taken, where we have taken the zinc oxide inside this like a potato. Why we have taken inside the zinc oxide? Zinc oxide usually create the vacancy, okay, oxygen vacancy. So it is used as a, let's say, for the cosmetics. Every girls they use. I don't know. I don't. Almost everyone use these cosmetics or beautification purposes or some skincare purposes. Okay. Sometimes we also use the skin infection there. We use the zinc oxide. So what happened that zinc oxide create vacancy of oxygen in presence of light. Okay. There is a transfer of electrons will be there, or vacancy transfer will be there. So then whenever vacancy transfer will be there, okay, there will be, let's say, charge will be generated. the D minus will be charge will be there, or D plus. Oh, oxygen will be going on the positive vacancy with the positive charge will be created. Okay, like this. Then what will happen? Let's say zinc oxide is there inside this zinc oxide, not potato is there. Then what is that? A positively charge will be generated. And let's say you have a DNA molecules which is tagged with the ETRB, some fluorescence dye. Okay, you see that first cases is this D. Okay, some fluorescence, your capsules are fluorescence, and DNA molecules taken which is fluorescence and loaded inside this. Then what is coming? Green fluorescence also is coming and red fluorescence is coming. DNA molecules are functionalized with ETRB. So if you can take also on images, if your capsules size are not changing, in these cases we are not assuming the size are not changing, then how you will come to know? So if you take the fluorescence stack molecules along with your drugs molecules, then you take the images, you will clearly, it will show the images coming due to the drug molecules. Am I clear? Why? The always size is not a final parameter to find out to decide whether drug molecules has been loaded or not. Am I correct, Dr. Urunita? Or whoever asked this question?
Yes, sir.
So that only, not only the one option based on the drugs and different type that can be there. Now you see that, very interesting. Whatever I wanted to show you, you see that how it's looking like. So you will be having a capsules, you size, shape. Okay, you can make it in different way. A pores will be there. Okay, pores will be there, and there will be pores and mouths, both will be there. You can load it. What, in which purpose we have used this? These capsules has been used for the cancer purposes. What we have done? EGFP fluorescence dye tagged siRNA we have loaded, okay, inside these capsules. Okay, and that capsules, whenever the siRNA were there, siRNA are negatively charged or some charge difference will be there with respect to the cell membrane. It has been found that this siRNA can be there outside these cells, infected cells. So this is whatever showing the skin cancer cells. So whenever it has taken inside the capsules siRNA tagged with EGFP, it has been found that if you say the single cell images, center is the nucleus, so it's go inside these cells, and even it can go inside the nucleus also. Okay, so if you see that siRNA we have delivered, and for the cancer therapy with time to time 1.5 hours to 40 hours, you see that here we have measured the absorption, how much it's coming out, okay, from this. So this is a siRNA sequence where the, let's say, 18 to 20 or nucleic acid base pair will be there. In 1.5 hour, its load, it can release 12%, which is almost 48 nanograms. So 48 nanograms is quite low doses, okay, which is sufficient to kill a cell. It has been found that 2 to 10 number of siRNA are sufficient to kill a cell. Okay, so very low doses. So you see that 373 nanograms of siRNA 48 hours is took, and if you see that it can kill almost very good amount of cells. So how it's come? So it pass, it's a complex, it's formed. Okay, it's passed through a journey, it will be coming RIS, some complex will be generated with siRNA, and it will be coming to the mRNA, okay, and it will be bombarded like atom bomb. Okay, so they will be attacked with the siRNA and bombard, destroy the mRNA, okay, which is one of the responsible factor for the mutation or the proliferations of the cancer cells. Okay, so any questions, anyone? And just I will be going to the imprinting of the properties of the capsule, some other way how you can make. Anyone can tell any other questions if have something related to this loading and releasing of drug molecules and targeting to the cells? Anyone? Okay, if some other example I will be giving, which is used for the genetic disorder. Okay, nanocapsules for genetic disorder. Okay, these cases, genetic disorder, probably this image is very much familiar. Oh, what is the time now? When I have to stop?
Sir, you have time, like at least 1 hour more to go.
I can take a actually gap for 10 minutes and then I
Yes,
can go.
yes, sir. Yes, sir. Anything that's convenient for you.
Okay, and then I will be telling with an example. I will be calling to my
Sir,
office to do.
sir, we have the session till 1:30.
Okay, so
So,
I hope that it's taking a gap will be a good decision for 5 minutes. Okay, 5-10 minutes. Then I will be telling is that some other parameter is really
Sir,
required to load this drug. Okay.
okay, sir.
so
So
can
this
I
is
ask
ask question, huh? I can ask
regarding
question.
this mm,
Hmm.
packaging and delivery?
Hmm.
I had asked about this phytoestrogenic compounds or phytochemicals delivery to different places. So one thing I would like to ask that whether it can be done through the change in pH, change in maybe magnetic forces can cause the drug to be released from the nanoparticles, but whether it can be done in a way that the drugs have been loaded, it is there, but it can come out in a dose dependent manner, or it is based on the time whenever the inherent concentration within the cell or within circulation of certain metabolite is lower, then the drug will be released, and when it is higher it will automatically stop. It will kind of like an automatic switch. Can it be done?
Automatic switch, one example I have given, whatever the body temperature.
Body
Another one,
temperature.
body temperature, recycle temperature, let's say periodic temperature.
But I am asking that in normal cases, suppose there is a lack of certain hormone in the body, and then I have already put these nanomedicines in a encapsulated format and delivered to the person, and in time it will be released until the equilibrium is reached, then it will automatically stop. Can it be done, sir?
Okay, so I will be telling one example. Let's say this your question answer are there with an example also. I'll be telling you. Let me check this example is there with me now. In any of these, let's say phytochemical drugs is artemisinin, okay, which is plant extract. Okay.
Yes.
If you want with temperature, come later, eh? Okay, with temperature that can be delivered. Fine. One example, very nice example I will be giving. Piperine we have used. Okay, let's discuss with this piperine. Let's check where I have presented last IIT. Let's check. Just a minute, quickly I'll be. Nice. Okay, now you see that. Let's say without since 1 hour left now, 1 hour without let's say for your organ targeting drug delivery systems. Okay. Let's say temperature can be an influence, pH can be an influence, whatever you are telling, the hormone can also be influence. Then what you need to have that your capsule should be response with the amount of the hormone. Okay.
Yes.
So that
yes,
if particular hormone are releasing or not releasing, if this capsules is very much specific to the hormone, not with the drugs, then whatever happen, that's the insulin delivery cases. Okay, I'll be again coming. So then what will happen? The capsules will be response. This can be default. It can be degrade. Okay, in presence of the hormone. whenever, or it should have something like a unfold. Okay, like octopus, it's unfold. Okay, when hormone are there, it will be unfold, medicine will be coming out. When hormone amount is reduced, it should be squeezed like this, so that there will not be anything outside. This close, all drug molecules or medicine will be there inside this capsule. But how long it will be there? Long term can also be there. You have to find out permanent solution. That's also you have to keep in mind. Insulin cases, if you have a capsules, when the blood sugar will be increased, the capsules will be unfold and it will be releasing insulin. Similar cases, when the blood sugar level will reduce to, let's say, 90 to 100, whatever the standard, capsule will be closed and insulin will not be released. So your idea is quite good. It can be designed. Okay.
Thank you, sir. Sir, actually, I was thinking about because nowadays we can see that there are small children who are affected with this diabetes type 2. So they are being using certain implants in their body, which has a sustained release of this insulin hormone. So why can't we devise it with other hormones like reproductive hormones or hormones that control the obesity and neurodegenerative disorders? That was on that line I was thinking. So thank you, sir.
That's okay. 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 Any other questions? Anyone? We can continue with the discussion. We have until the time 1 o'clock, na? 1 or 1:30.
Sir, the session is up to 1:30, so we can have an interactive session before wrapping up the session. So it can be like up to 1 or 1:30.
Whether everyone are there or everyone is taking break, so that I don't have any problem, I can continue.
Sir, anything that's convenient for you.
Okay, fine. I will be showing a very good example, okay, where the organ targets are there. So this polymer particles effective for the organ targeted purposes. I see that. So organ targeting drug delivery systems of copolymers, it's very quite good. This is a work of a PhD student, recently has been awarded as a best PhD thesis award by the Society of the Biomaterials and the Organ Transplant. Okay, good. So what we have done that, if you see that, nothing is very much special. We were making some polymer. You know what is the polymer? We know, everyone. Conjugations or the chemical bonding formation of between the mass, which is covalent bond, and polymer is a long chain molecules. What we have taken? We have taken 2 amino acids. We know everyone amino acids. Amino acids have a bulk R group. Amino acids have hydrogen. Amino acids are NH2 and amino acids are COOH. So whatever the amino acids are there, whatever we consume from outside, that is, let's say, essential. Whatever body produce, these are not essential because that is body produce. What we have taken, that we have taken some amino acids, let's say phenylalanine or glycine or histidine, whatever is there. We have taken in a different extent. So P1, P2, P3, P4, like a library we have made almost, let's say, 50. And distinctly we have selected 4 or 5. 1, 2, 3, 4, 5. If you see that, the compositions will be different. Let's say 1:2, 1:1, 1:3, 1:4. And then it has been made. You see that although they are the amino acids of different molecular structure, due to that, they will be forming the amino acids based polymer particles with different size and shape. Okay, amino acids based polymer with different size and shape. Okay, this is this. Then what will be happening? Okay, in terms of the number of mass, they will be different. Means with differentiating the extents of the mar, you are functionalizing. Am I correct? Number of mars are different, means different number of functional groups will be there and they are functionalized differently. Some of you initially was telling that we can functionalize with some chemical moieties. Here what we have taken, this is also a similar type of process, but in some other direction. We have taken different mass to functionalize this with functional groups in terms of the mass. So let's say we have prepared this. Now what we have done? Then let's say P1, P2, P3, P4 we have taken. Then we have challenged again the live animal. Okay, let's say a rat or mouse, whatever we have taken. So whenever we have injected 1, 2, 3, 4, 5, we found that based on the chemical compositions of some can attack to the lung, some can attack to the heart, some can attack to the kidney, liver, and breast. Then what is this thing is that, say you have made a library of the particles which can attack to the different organ. Okay, if you remember or if you have some experience with the literature that if cancer spread throughout the body, it's called the metastasis, and it's spread lungs, heart, kidney, liver, and breast. If you see that P1 can attack heart, kidney, liver, and breast. If you take P4, it can attack to the breast, and if you take P5, it can attack lungs, heart, kidney, and liver. So if you take the mixture of these all, then what is the option is there? That these all capsules, some percentage are able to attack in the various organs. What about the first slides? I have shown that nanoparticles can translocate in the various parts of the body and various organs. Example is that if the nanoparticles is loaded with, let's say, phytochemical. This we have loaded with phytochemicals, let's say piperine, okay, loaded and then deliver. We have found that if it has the different organs, diseases, this can be used for these purposes. So I think I am just clear to you that based on the formation of the functionality and the varying the functionality of the nanocapsules, you can target to any organs. So this is actually main idea. So what we have done is that first taking this, and then what will happen, we have challenged this with somebody asking about the toxicity. Then what we have taken in the cell, a number of cells we have taken. Okay, 1, 2, 3, 4, 5, 6, 7. Itna number of cells here. So we have taken normal cells, we have taken cancer cells also. Okay, triple negative breast cancer cell, MDA MB231. We have taken A549. We have taken even in PC12 cells, neuronal cells. So every cells we have taken, and we have found that it's quite viable. You see that it's a with the concentration dependent toxicity will be there because number of cells will be killing at a higher concentration many cases, and some cases you see that the with change in the concentration even there is no change in the cell killing. So based on your requirement, okay, which dose you will be taking or which extent or which amount of capsules will be taking to kill the cells, or you have to take so that all cells will be surviving. Some other is there. So this is one type of just test for the toxicity. But toxicity usually study for 21 days to 29 days. It can be study for 6 months or 1 month. You have to inject the particles up to 2 mg, acute toxicity or something else, whatever the term is there, based on the regulatory body. You have to challenge and you have to take the blood samples and you have to calculate the parameters, blood samples parameters, it's a cytokine, chemokine, blood sugar level, uric acid level, whether your animal is dying or not, animal behavior is changing or not. So that are the tests you need to do to test the toxicity. Okay, fine. So these cases, what we have done, we have done some hemolysis. Hemolysis is a parameter experiment where you have to take the red blood cells in some solution, let's say some biological solution, and with the red cells, different extent of the capsules you have to take, and you will find that, okay, at different extent of the capsules, whatever you desire. In the first cases, let's say P2 cases, even 500 microgram per ml with the blood samples, its hemolysis is 5%. It is means that 10 up to 10% you have consider, but there will less interaction and it is not killing or destroying the red blood cell. Similar cases P2, you take the P3, you take the P4 and P5, they are quite hemocompatible in nature. Okay, what you next do, and you can do also, you can, it is a chick model. Chick model means you can artificially create the chick inside this egg, from the egg, and you can challenge your nanoparticles against the chicks embryos, okay, and you have to take these certain doses, 1 microgram, 10, 100 micrograms of this, and you will finding that if it is not allowing to grow the cells, okay, or the membranes, okay, or the blood vessels, it is means that it's creating some toxicity. So check, so cell based model, embryo based model you can do, and some other model you can check that whether it is toxic or not. So what we have done here, we have used the AI model, artificial model, AI, I mean artificial intelligence, okay, AI model you have used with some mathematical formula we have used there, okay. Let's say it is not there as a lot. So based on this AI model we have used, and we have checked that almost 21 parameters, including the pAs, other thermodynamical parameters which are responsible, which are changed after the interaction, and it's either it is toxic or non-toxic. So if chick is forming inside these eggs, they can also be die after the interaction, okay. So that also the way. Now what you can do, that you can do the network pharmacological study, okay, if someone would like to do some research in this field. And from network pharmacological studies, if you are following some steps, you will be finding what is the responsible genes or proteins or amino acids are there, which is will be actually interacting with your nanoparticles, okay, or the polymers nanoparticles. So you will be having, so we have tested various cases. These cases we have tested, okay, and found that for breast cancer cases, whatever the polymer particles I have shown, it can interact up to 21, okay. So then molecular docking also you can do. What is the steps I am telling? Then you can take some doses, okay. This weight has been measured there to find out whatever the doses are there inside these capsules. And in the second cases, we have checked that the drugs will be releasing stepwise, okay, and some certain concentration are there which is helpful to kill this. And some other cases, what you do then, not only killing is very important, so whatever the cells are there, they can grow or not, okay. It has been found that control P4, PP4, these cases, they have different extents of amount. They can also, if you don't want to grow the cells, it will not grow, or if you want to grow the cells, it will grow based on you. So it can use for the regenerative purpose also. So what is that? Then what is the take-home message is there? You have a capsules, they can be designed in some other way. They can target to the different organs, and you take the particular one and you fill with the medicines and deliver it. It will go, let's say, into the breast. If somebody has breast cancer, okay, some other diseases, okay, then it can be used for the treatment of the breast. Fine. So this is one type of thing is that similar cases we have taken some other example I can show, okay. In vivo cases, this can be used for the regeneration of the what is called the muscles or tissues, okay. So your medicines, if loaded, you challenge with in the animal models, If you see that in 7 days, okay, with treatment cases, in 7 days it can be repaired. Okay, so it can be repaired in 7 days. And what you can study, lot of immunological parameters is there in cellular microenvironment. Many cytokine chemokines levels will be changing. Based on that, you can analyze your results. What is the role of the microenvironment, cellular microenvironment, okay, and you can compare with the literatures, okay, and what is the factors is really will be working for this, okay. One more example I can tell is that, which is very interesting, is that let's say some neuron cannot be generated, okay, neuron cannot be regenerated, but if you can have the idea what is the region of neuron degeneration, lot of factors can also be there which is really harmful. So whatever the question was there, neuronal parameters or neuronal factors you can find out, okay, if it is altering then you can tell that your materials is toxic in nature. So neurodegeneration will be there. Why neurodegeneration will be there? There are various factors can be there. The chemicals will be there. Some others medicines are there. Let's say after taking the medicine, somebody has strokes, okay, heart attack, some other things is there. So that the side effects are there. Okay. So these all are coming under the toxicity of the materials. Okay, toxicity of your medicine. Apart from that, side effect will be there. So what you can, what happened that, so a lot of neuro degeneration or neuronal effects occur, then people can have the disease like Alzheimer, or it can have the disease like let's say Parkinson disease. So a lot of things can be there. And what can be there? Let's say somebody has spinal cord injury, then what will happen? Somebody will not walk. Okay. Then you can think of that. Why it's happened? Because lot of reactive oxygen species generate in the spinal cord. It can soil, it can become ingrate, it's accumulate lot of fluids due to the oxidative stress generation. Okay. So one example I can give that a hydrogel amino acid base can also be there. One example, okay, you can give some shape, size, okay, and it may have the properties of the fluidity, okay. It can injectable. If I show that it can be injectable in various way, let me check. Okay, where I have shown this injectable property. Hydrogel can be injectable in nature. Let's see. Okay, so what the property is that this hydrogel will be like this. Okay, you can shape and size, and it can be injectable also. Okay, it will have a different mechanical property. Somebody were asking about the mechanical property. It can have the different mechanical property. It will be swelling, it can degrade. So usually we want that whatever materials we inject inside this body, it will be swell and it will be degrade. Okay, it will be can swell and it will be degrade. Fine. Okay, and temperature change. Then what we have done, whatever the example I have given for the neuronal recovery, we have taken neuronal cells from the puff and we have allowed to grow a 14 days puff, okay, and then allowed to grow inside this hydrogen, and we have found that within 10 days lot of neurons can be grown. So you see that how the neurons can be grown. If I am not going to details, so different size of neurons can be grown. Okay, you see that. So this is one of the other example of that. Okay, neuronal cells can be grown. Not only that, whatever the oxidative stress generated, we have taken this hydrogel with creating a artificial oxidative stress with hydrogen peroxide. Whenever we have given the oxidative stress and we have taken the neuron, we found that this hydrogen and polymer or nanomedicines can be helpful to reduce the oxidative stress. Okay, and it can be used for the purpose of the neuronal growth. Okay, these are the idea. So a lot of experiment has been done. Concept are there. Let's say polymer will be there. This will be challenging. Okay, there will be oxidative reactive oxygen species. Let's say in brain or spinal cord. Lot of this parameter will be changing, let's say VGF, HIF, all others. Many of you know better than me of this. Okay, mitochondrial potential changes will be there based on the changing. Can you drop this here? After that, I will be signing it. Okay, okay, because I'm taking a class. After the finishing class, I will be taking. Okay, and this neuronal growth also will be there, and it should recovery will be there. One more example I will be giving that. Okay, it's a very quite good concept or there. Carbon quantum dot. Okay, it is apart from there. Okay, it has if you see the cheek. Okay, if you cheek are there, it has been taken inside the cheek. It has been tested that cheeks are not dying after taking the carbon quantum dot, which is mean that it is quite not toxic in nature, and it has been challenges against the tumor. Okay, and if you see this, what the side calipers is showing, this the tumor diameter is different. Okay, and that has been checked, and we found that within few days tumor size can be reduced within 21 days. Okay, tumor volume will be sizing, and different organ cases has been checked that there will not be any change in organ if it is toxic in nature. This itself, these particles, nanoparticles is toxic in nature, then there will be a change in the morphology, size, shape, or the different organ, let's say liver, kidney, spleen, heart, lungs, pancreas, lot of things. And it has been, after these dissections of these rats, it has been found there is no accumulations of the water, so either in liver or somewhere else. So it's a quite good in nature. So histolysis, hemolysis, okay, everything has been done. Okay, that will be doing. Quickly, I'll be telling two more topics. Okay, where you can use for the immunotherapeutic purpose. Let's say arthritis, where that some example will be there, where which can be used for the inflammatory diseases. Okay, lot of inflammation can be there. So inflammation, bowel disease, arthritis, let's say systemic inflammation, that can be there. So this is a polymers we have synthesized among the library. Okay, among the library you can prepare any. Okay, let's say you have able to prepare, then this size is porous in nature, no drugs molecules has been taken. So toxicity has been checked against the raw macrophages. You know, the raw macrophages is the some immune cells. Is a standard cell used for the therapeutic purpose of this. Okay, something has been taken and we excite the raw macrophages, naive raw macrophages, and it's secrete, let's say, lot of chemokine, okay, cytokine, and it's increase the immunity. So we have checked this with the PC12 cells, which is a neuronal cells. It has, you see that, quite biocompatible in nature. The interesting thing is that these nanoparticles without the drugs can go inside the macrophages. Okay, so these nanoparticles are tagged with the fluorescence molecules, and it's go inside this. Okay, and what we have done, we have checked that what about the parameters. Let's say it's a lollipop type of network pharmacological study has been done. A lot of, let's say, genetic components or these parameters are there. The NF kappa beta, IL-6, IL-1 beta, TNF alpha, INOS. These are interaction has been checked with the capsules, and we found that these are the major the components. Okay, play the role for the arthritis. Okay, almost rheumatic arthritis, almost 20 play the role. Then what we have done that whenever we have studied that, we have created artificial arthritis. Okay, on 15 days. So this is the treatment, same control, positive control treatment. Okay, and then in 15 days we have seen that rheumatic arthritis has been generated, and on that 15 days we have given the first dose. So first doses we have given, then we have given second doses on the 22 days after 7 days again. So 15 days and plus 7 days, 22 days. So on 25th days it has been found that, you see that, so arthritis has decreased. Okay, how we measure the swelling, redness, other things, measure the left paw thickness, right paw thickness, and we have found that it is clearly working very nicely. Okay, and the thickness, rheumatic arthritis, is decreasing. Okay, then it's a very nice way. It can be used multiple ways. So what the thing is that, so there is a polymers, okay, or nanoparticles you can take. You can take some raw macrophages, you check which parameters are influencing to reduce the inflammations of the cells. Then you create the inflammations of the rats. Okay, you will be checking initially inflammation before the treatment, you see, and after the treatment, and you check the whatever the parameters is decreasing. Now we come back to the inorganic. Okay, whatever is, maybe many of you are excited what we are making for our startup company. So we have made, let's say, this drug resistance antibiotics are there, which is working under this. Okay, so lot of infections can be generated. Okay, we all very much cautious. Whether we all are not cautious about the our skin. Anyone? Female faculty members, whether we are cautious about our skin or not, whether we are cautious about the infections or not. Anyone?
Sir, irrespective of gender, everyone is cautious about their skin, especially due to
Irrespective of the gender, everyone is very cautious about the skin, and we don't want that our skin will be infected. Am I right? Okay.
Right, and sir, overexposure to UV radiation nowadays is also.
So over the UV radiation or over the pathogens. Okay, in pathogens also we don't want that some, let's say, whatever we suffer during the COVID. Okay, we don't want that. No? And whatever the image has been shown, that you see that lot of infection can create in our body skin. Am I right? This infection can be UV radiation, and this infection can be for pathogens, and lot of virus and bacteria on fungus can also be there. We want that the relief from it. So one, we have introduced something. Let's say somebody has the catheter putting inside this body. Infection will be there. Somebody has operation. Somebody has, let's say, C-section. Okay, lot of pathogens go inside this body later. It's create a problem, pain. So a lot of antibiotics has been prepared, which can actually have a electrochemical effects. Okay, we have got some 4 patents, which can actually, these materials can attack to the fungus and bacteria also. And if deep tissue infections are there, that you can use also bypass. You can study lot of things, whatever the pathogens are there. Okay, these are the way has to go, which the protein moieties of the different fungus or bacteria responsible. You can study it and check whatever the nanoparticles are there, whether they are interacting or not. Okay, lot of, let's say, a list are there. We have checked for 36 like this. Okay, these are, and then whatever happened, that we have infected the skins, because we infect and check. We have infected the skin, and we have found that with 9 to 10 days, okay, this infection can remove. So infection come other cases also. Let's say something has been cut on our finger. Okay, finger cut, and later it is being infected. It should be prevented. So many cases it has been that whatever the conventional antibiotics are there, okay, they become resistant after using some time. It's a very common. Okay, and few less 8 to 10 antibiotics are there which is used for these purposes. So if we have an alternate one, whether it is not good, or if you use our space and like a sanitizer, okay, if we go out in some environment, we are going to hospitals. Okay, hospital is a place which give the infection. We are going out for marketing. We are going exposure. We use mask. Other than mask, the pathogens can be there on our skin, other places, and so if you take it on it like a sanitizer and some other cases, it will protect. So it will not only cure, it will protect this body also. Okay. So these are the products are there which can be used for the infectious diseases. Okay, these are the products. The students, the lab made products are there. We already, now we are analyzing lot of things, and toxicity, skin, other type of side effects or not. Okay, So this is there. It can be used for cosmetics, for protection, so many things. Hospital rooms, okay, for any skin care purposes. Even this can be used in the kitchen also. Okay, if you make a layer inside this kitchen, it can be protected. The way you can protect your skin. So these all you can make it in the powder. Let's say some powder we take somewhere on the, let's say those who are the cricketers, they take some powder on the cheek, protect from not only UV. So they, whenever they sweat, some fungus can grow on the skin. Many have these fungus grow on the skin. Okay, many parts of this body. So if you use, let's say you are coming from the office, you have exposed or a lot of environment you do not know, and then you can take it. Okay, so let's say whatever I have talked with that, so many patents, publications are there, the funding agency are there. Okay, those who have done for us. This is the landscape of our lab in the IIT BHU, where the students, we have to maintain very the clean environment, okay, to do all this work, because certainly there will be always the confusion, which is the nanoparticles and which is the dust particle. Now quickly ask me the questions, and then I will call to my assistant who will be giving a form for the patents, so that I can tell you the steps, what the steps required to file a patent and how to go there. You ask the question continuously and I will be taking out some other things. Okay, ask me any question, because 3 hours is very less to understand so many things. So let's say now it is 12:51. Am I right? 12:51. So I can tell how to file the patents in 10-15 minutes. Any question? In the meantime, I will be telling about the what is required to filing a patent, how you will be going. Any question? Whatever we have discussed. So many things I have not discussed actually.
So I would request the participants to kindly put forward questions. Sir has wonderfully conducted an interactive session. Now, if you have any doubts, any queries, something you want to discuss on, please feel free to put your questions. You can either put them in the chat box or you can directly unmute and ask.
Yeah, you can directly ask, and in the meantime, I will showing how to go for a filing of patents. And then I will showing if what is the usually are there, okay, and what you need to think of it. Anyone?
Do we have any questions? Please unmute yourself or put your question in the chat box. While sir is preparing for showing a presentation on how to file a patent, we can have questions on all the things that has been discussed till now.
Sir.
Yeah, yes, you're audible. Just
yeah.
Yes, you're audible.
You can ask any question.
What yes, what might be the background to reject a patent?
Your question, it's not.
Actually, can you put it in the chat box?
So
it's not clearly audible.
A patent can be. Oh, wait.
Tell me. I'm in a meeting. Okay, we'll talk to you. It's another one, half an hour will be going. Maybe I can meet after lunch.
Ajoy Kumar Das, sir, if you have your question, please kindly unmute, or you can put it in words in the chat box.
Myself, Kaushik Sarkar.
Mm-hmm.
Actually, we have seen that the thalidomide is a bird defects producing. It's also known as teratogen.
Mm-hmm.
The nanomedicine also helpful to use this for the teratogen, beneficial effect for teratogens.
You can use it for therapeutics. We want to
Therapy,
use it for therapeutics.
therapeutics.
Yeah.
And is it also person specific dose? I think it also.
That's called the personalized medicine. Okay.
Personalized medicine. Okay.
So if somebody have some, let's say you are taking some drugs, somebody taking that can be resistant. Okay, that cannot be, may not be work for the other purposes. So that type of are there. So that cases personalized, you can make it also. You can make it personalized also. Okay, na anything?
Okay.
Okay.
Any other questions? We have time. We can take a few questions.
Excuse me, ma'am.
Yes.
Can you hear me?
Yes.
Yes. Tell
Yes.
me.
I put my question in sub box actually. Means the
Yes,
question
that
was
would be better.
what are the reasons, main reasons? Yeah, main reasons to reject a patent.
भानु जी, आर यू इन दी ऑफिस? एक ना पेटेंट सेल का जो ब्लैंक फॉर्म है, नया फॉर्म बनाया ना आपका, मेरा वो मेरा पर्सनल ऑफिशियल ईमेल आईडी में, नॉट डीन्स ईमेल आईडी, थोड़ा भेज दीजिए ना. आई हैव टू, अभी भेज दीजिए. आई हैव टू टेल समवन हाउ टू डू इट. ठीक है ना? आई मीन ऑन, आई विल बी कमिंग इन आफ्टरनून. है अभी थोड़ा उसको भेज दीजिए. आफ्टरनून में आई विल बी कमिंग अराउंड 3 o'clock. हाँ ठीक है ना? ठीक है. तब अभी थोड़ा पेटेंट सेल का फॉर्म मुझे ईमेल में शेयर कर दीजिए. आई मीन इन कन्वर्सेशन विद समवन, सम ग्रुप ऑफ फैकल्टी. ठीक है, अभी कर दीजिए. सो हाँ, व्हाट इज द क्वेश्चन इज देयर? आई जस्ट आस्क्ड टू माय पीए टू सेंड ए.
Professor Das, you are not audible because of some reason, so kindly put your question in the chat box.
Madam, he has already put the question in the chat box.
Okay, so yes, so what are the main reasons to reject a patent? Ajay Kumar Das is asking.
What is the main reasons to reject? I will be coming to the patent. Other than the patent, whatever we have discussed in the now. Okay. I asked to my PA to send to a form. I will be discussing all these things.
Okay, so Professor,
I will be coming.
so there is another
we have
question.
half an hour. We will be discussing about the filing the patent. Okay. Other than this,
so there are, yes, sir. There is a question from Professor Rajarshi Ghosh. He is asking, what's the best possible way to deliver nano-encapsulated drugs to fish models kept in lab culture, especially if we want to treat fish gut exposed to toxicants?
What are the best possible way to deliver nano-capsulated drugs to fish models culture, especially if you want to treat fish get exposed to toxicant? Okay. Although I have I don't have much experience with working with the fish, but I feel that with the feeds of the feeds can be given. Okay, if there is a option to inject the fish, that also can be done. So by injection way or by feeding also can be given the nanoparticles with the medicines encapsulated inside this. So this can be the two possible way, very easy possible way, because lot of people work with the zebra fishes in the similar way. But if fish are very small in size, then you have to use the feeding process.
Okay, sir. So there is a question from Obhik Chaudhary. He is asking, how successful are green synthesized NPs in the field of nanomedicine? How
So,
successful are green synthesized NPs in the field of nanomedicine?
okay. So, first of all, you have to thing is that what is the nanosynthesis, green synthesis method. Okay, green synthesis means you should not have any toxic effect with the materials, or synthesis method should be followed without a chemicals which is very much toxic in nature. Okay, so let's say you are taking the plant extract. If you take the plant extract, okay, then that can be used. So this is quite successfully people have made, okay, green synthesis using the plant extract, because plant extracts containing lot of materials which is not toxic. Okay, let's say one is the lemon, citric acid. Citric acid you can use for the synthesis of the gold nanoparticles, you can use for the silver nanoparticles, or the lemon, whatever, citric acid, tartaric acid, okay, and ascorbic acids. In presence of protein also, in presence of peptide, in presence of polymers, okay, you can make the nanoparticles. It's quite successful, quite successfully synthesized, and they are sometimes they are non-toxic in nature also. Okay.
So any other questions?
Let's see, somebody has sent.
Sir, as of now, there are no other questions. So, sir,
Okay, then I will be coming to the point. I'll be signing and sending you. I'm in a class. Okay. Thing is that we are very much eager to know what is called the patents. Patents is like IPR, intellectual property right. First, we have to know. I just asked to my PA, will be giving the form how to do that. So this is an intellectual. Let's go to this. I'll be touching this one. Okay, full screen. Okay, I am just doing the okay. So let's say first you think that what is patent? Patent is the intellectual property right. What is that? If something, let's say you have invented which is non-obvious, as not done by others, the new synthesis method. In India, you can have the scope to file the patent, the new, let's say, synthesis method, new method of fabrication, new method of, let's say, some way. So in India, you can do the filing your invention, which will be calling intellectual property right. It is your things invented by you or your group members, research group, which is not obvious. What is mean the obvious? It has not done by anyone else, or somebody has done something with some method. We have improved the method which is not obvious, which is not known. Okay, so that is called the intellectually new things to file. Okay, so in that cases, so that is that the process. Even if you write something, let's say, that will be coming in terms of the copyright. So process and your writing. So writing can be in a copyright. And let's say if you prepare a new materials in India, let's say new drugs you have discovered, you cannot file that in India as a materials products. In US and some other country, you can file the products, the new materials. Why in India it cannot file? Because if somebody prepare a materials and there will be a monopoly in this, population is very high. If somebody do the monopoly like this indigo, it will be collapse. So in the economically, let's say, weaker section people, that will not have the option for them to buy it. So products cannot be filed for the patents. Only the process can be filed for the patents in India. Okay. So now let's say I'll be telling you how you can file. Let's say I'm trying to find out a form. Okay, form has come. My P has already been forwarded to me. Okay. Whether some Word file has been shared with you, whether it is visible to you.
Yes, sir, it's visible.
Yes, sir, it's visible.
Visible. Now this time. Okay. If you see that, there usually will be a form like this. In the step by step, let's say I have made this for the faculty members and the students for our, okay, where first you have to file your name, title, from where, other things. So patent can be filed against your name, or patent can be filed in the name of the organization on behalf of the organization you are working, or those have offer you job. Usually those we are working in the government institute, all the patents can be viable, or it is ethical to file against the institute. What is the advantage of that? If you file the patents against the institute, most of the institute, they give you the money, whatever the expenditure, the cost of expenditure. Okay. If you file in my name, okay, if let's say in my name, then all the cost has to bear by me. When somebody will be filing patents individually, if somebody is not attached with some organization, like a government organization, okay, individual name can also be there. And if somebody is working in the industry, the patent will be the property of the industry. For the academic institute, patent will be the property of the academic institute, let's say in IIT, or let's say in Calcutta University. If they give the rights, not to give the right to an individual person, then the patent will be in the name of the institute. Then what is the advantage? What the advantage will be getting by the inventors? Okay. So there is a rule is that both the party, the institute, those who are giving the money for filing the patents, and as an inventor, they will be having a share. Let's say usual share is like this, 60-40 or 40-60 in this ratio. So why in institution cases it is 60% or 40%? Because they pay everything. They give the facility. They give the working environment. They give my salary. We are the employee. Okay. This is the advantage of filing a patent from the academic institute. But for industry, everything you have to have in the name of the institute, a company, and many maybe royalty, let's say some percentage can be given to the name of the inventors. So inventors, who can be the inventors? Inventor can be the PI, inventor can be the PI means faculty, and inventor must be there as a students, because very less PI or professor, they do work on the bench. Students do the work in the bench, and sometimes they help to create the idea, new idea. So patent always will be there with the new idea. So it's a creation of both the PI, the professor, and the students. And many person can be there, those who will be involving to filing the for the invention, creation of the invention. So that also can be there. So if somebody had designed something that is a new design, okay, so that also can be filed as a that will be trademark. Okay, trademark. So trademark also is a intellectual property. Let's say Adidas trademark, let's say Bata trademark, let's say some others, Nike, they are a trademark. This is the trademark. So with the trademark, that is also intellectual property, people will come to know that this is a this trademark also a property. Let's say our Tiffin Healthcare, the Tiffin Healthcare symbol is there, that is our. That is, I have filed on behalf of my company. But whatever the other patents are there, I have filed on behalf of my institute where I am the PI. If it is commercialized, then I can get the shares in terms of the monetary benefit. Okay, so if somebody open his own company, that can be used for himself for one, or that can be sold to others, to other company. So why we file the patent? To protect our invention, so that somebody cannot thief it. Let's say Jagadish Chandra Bose has discovered the betar, okay, radio frequency based communication, but that has been stolen. Somebody else has stolen and has been taken in his name, because Jagadish Chandra Bose has not protected this. So for first cases, what usually technical institute do, that whatever the instantly developed technology development are there, they protect in the name of the institute and inventor's name. Okay, now if you found that non-obvious means it is not obvious to all, it is unknown, okay, then that can be filed for the patents. So non-obvious things has to be keep in mind. So whenever, how you will come to know in a non-obvious, there are a lot of literature are there, there is procedure are there from which you can search the your things is new or not. Okay, so slowly whenever something will be there in your mind, you have to have the knowledge, the what your nobility of the work will be there. Now thing is that, so let's say then I will be telling you, let's say there will be form, all details will be there, there is a governing body who will be helping you for filing a patent. Usually there will be a center, or the, let's say I am a chair of the sales, I am officiating, I am the officing head. Okay, I circulated the form with the proper criteria I will be showing. They will be filling the form, they will be telling that yes, this is novel, this can be filed for a patent. So they will be applying to my office. There will be a regulatory body would be there, and review committee would be there, those who will be searching and check that whatever the claim has been made. So claim, I will be telling you how the claim are there. Okay, the claim will be they will be documented based on the claim. They will be saying that this is a new one. Okay, you can go for. And institute will usually pay. The payment term for industry, payment term from institute, and payment term from MSME and others will be different. Okay, so small scale industry, big industry, corporate industry, or educational institute, the charges will be different. And for the individual persons also, charges will be different. What usual question will be there in the, so this is a general information. Then have to have a classify the invention in a new products or new process or the composition of the new material. So it can be a mixture formulation, let's say pharmaceutical formulation, new method of synthesis of nanoparticles, new structure, new architecture. Let's say Lotus Temple in Delhi, the architecture design has been protected. So design, nobody can copy it. Okay, let's say earlier it was there, let's say some song has been written by, let's say, Solil Chaudhary. Okay, some music has been invented, so that is copyright. So cassette or everything was the copyright, so production will be there, copyright will be there. Without the permission, nobody can copy, nobody can sell. Okay, this right is there. So it can be a new product, it can be a new process, or it can be a new composition. Okay, so you have to write like this. They classify the invention, they plan from stepwise, you fill it after the literature. Then title of the invention, you have to have a title. Let's say in the process, you can write a new process of synthesis of materials used for the, let's say, cancer treatment, like this. New process of synthesis of a medicine for the pharmaceutical product for the cancer treatment. Okay, application. Most of the cases we hide the application, we only tell the process. So you have to very carefully write. So if you are not, so this is the preliminary work. Then description of the invention which can be publicly open. So something should be there which will be available publicly. When it will be available in publicly, whenever your documents has been registered in the patent office, like a court, patent office also will be there, lot of lawyer will be there, patent attorney will be there, those will be drafting. So this will be a preliminary information you have to give okay, to your patent attorney. So you see that you, according to you described the invention in a point-wise point, how it can work. So how it will be working. Then short description on the various component of the invention, which materials you have used, what is the percentage, what is the purity, all other things will be there. Okay, everything will be there. So you have to there. Then you have to mention the nobility of the invention, how it is noble from the others. So you have to do proper literature survey, and you have to mention the nobility, the care noble care, how it is noble. So step by step you have to tell that. And present stage of technical involvement, development. So we everyone want that whenever a technology is protected, this will have the two interests. One, it will have the financial interest, and it will have the commercial large scale production, okay, possibility. And there will be like TRL 1, technology readiness 1, 2, 3. Technology readiness 1, 2, 3 will be there when, let's say, it will be in the idea stage, or proof of concept will be there. Then 3 to 5, let's say, for biological product, you have done cell-based study. Then it will be coming animal study. Then it will be clinical trial. When clinical trial will be there, it will be like a 9, 10. And whenever it is ready for the market, it will be coming onto the 12 stage. Technology readiness level 12. Similarly, it is there in terms of the technology development. Then will be there MRL, market readiness level, whether people are ready to buy your things. Okay, why it will be buying. So development of technology is different than the development of your product in terms of the feasibility, whether it will be going in the market. So these are the very less points will be there. Similar type of forms will be giving a patent attorney also. Now, who will be writing the patent? You will write, or patent attorney? Usually, it is very advisable that some patent lawyer or attorney will be there who will be helping you to draft this patent. Okay, because faculty members are busy, students are very much good in technological, but why we'll go to a lawyer? We go to a lawyer because to check the legal, okay, legal terms. We have to apply through a legal terms. So we have to have a legal terms. Okay, so legal terms will be there, which will be have to write in terms of the legal term. Okay, that's now, let's say these are very few points are there. If institute want, then you have to sign address, and you have to have a lot of inventors name, those who will be signing, it is must. Then let's say it's go to me, and with the examination with the committee members, we give the clearance, okay, it can go for filing the patent. Now seeing some other things will be there. For inventor consent always has to take from, let's say, from all inventors, they all are agreed, okay, they to file this patent. You have to take and sign signature of all inventors is there. Who will be the patent attorney? You have to write, you have to give the right to the patent attorney. You have to give the right to the patent attorney that he or she will be drafting for you. Okay, fine, this is the first step. Then you have to send it. How the documents will be looking like? Okay, let's see. How will be documents will be looking like? Let's say very early stages, whatever has been granted, I will be showing you filing. Okay, draft copy. So there will be a claim form. Let's say granted one, I can say. Okay. So you see that, okay, first we have to make an abstract like this. What is, let's say, facile, hollow, mesoporous, chiral, polymeric nanocapsules, and a process for its preparation. So like this, you have to tell abstract, usually within 100 to 150 words, the whatever the main. Okay, abstracts means basic information about these inventions and what is the important points are there. So this will be there. Okay, and you have to give a schematics, or some figure which will be reflecting for the main invention. Then claim will be there. Okay, claim, how it will be looking. Let's say these cases, I am claiming these are in this direction. We have synthesized, we have used new materials like this 0.12, on which basis I am claiming that it is can be filed for the patents. What is new? Method, you have to have a method to mention. Methods, what is the chemicals, what are the parameters you have used, each and every points have to use. And you have to have a landscape. Let's say 2 grams to 5 grams if you use, you will get the products. Okay, like this, so many claims will be there. Based on the claims, how much, there will be a patents office rule are there, how maximum, how many claims you can do, and whatever the pages will be there. Based on the number of pages, you have to pay that. So everything related to the money. You are claiming, if you granted the patents, you will be, if you sell it, you will get the money. Similarly, for this patent office, you have to pay them. So the claim will be there. Okay, then abstract is there, claim is there. Then what is left? Complete specification, how it will be looking like. So it is like a paper, writing a paper. Okay, you have a title, in for which field, what is the background of this will be there. Okay, you have to give lot of citation, in which background it is coming. And let's say you have to cite the other invention are there. Okay, some patent numbers you see for Chinese patent. Okay, let's say it's a Korean patent, with respect to that it is new, something has been done and it is improved. So objective of the main invention, which purpose you wanted to use, let's say biological molecules, okay, medical application and therapeutics. So objectives is there, why you have done. So lot of objective sides. So summary of the invention will be there. It's like abstract. Okay, actually what is telling. Then you have to give lot of figures, supporting information, like this, similar things will be there. So this is the repeated of these two earlier other file, but this is will be a complete specification. And example of experiment, various, let's say example on synthesis, characterization, okay, cell viability study, whatever the study, you have to step by step mention with detail, each and every detail. So you are filing patents means, okay, you will be disclosing all your information here officially, and which will be registered in a code. Okay, and everything will be reserved for you. Let's say you are buying some land, it will be your name and it will be in the, let's say, registered papers will be there. Okay, where the sign, code sign will be there. So similarly will be there. Okay, so sign paper will be there. Let's say it is not your job. If you wanted to do, you can do, but if you are not expert, it will be very difficult for you. Now there is a question was there, why patent, this is there. So how it's looking like, so completely, and you have to give the figures like this. What is the figure, how it looking like. You see that Lalit Ambastha, who is the agent for the patent applicant, so lawyer, who actually you have to give authority to them with the agreement, both the party will be signing, and he will be dealing everything in the cost of the money. So you have to give the money. Okay, so money will be there, involve everything for everything. Now how it is looking like, let's say final draft. Then let's say whenever you will be filing, the filing documents will be coming like this, confirmation of filing with a name, number will be coming. Okay, let's say some number, what will be coming, the filing means some number will be coming. Let's say some certificate live will be there, and they will be giving a number. You see the application and application number. So it has been dated of filing May 3rd, 2021, and it has a number. So once you get this number, it is means that you are fearless. Nobody can copy your things. So you are free from fear. Now your things has been documented. Okay. So filing means you are free from any tension. So nobody can copy it. Okay. Your everything is right. You're right. Now question is that when I will be coming to know they were this. Again, I am repeating, if you see that it is non-obvious, nobody has done, it is quite novel. Okay, it's not matching. with anyone else, then you go for filing your invention for protection. Now question is that if you publish the paper, whether you can find the patent? Yes. If you publish the paper, is it new method? Then you can approach to your patent attorney to make it in this documentation form, and within 9 months you can file your invention in your name as a patent. Question is there, how much cost will be there? Usually cost is varied. Whatever the cost will be there for individual person, let's say if it is 10,000, for institute it will be coming 30,000, for industry it may come 6 times to 10 times more, because industries can pay more. Academic institutes are public funded, so they need to pay less. Individual person, they have the limitation of earning. Okay, government has given this course. Okay, if somebody is not attached with any organizations, doing some research work at home, they have to have the scope also to finding the patent. So that is the list. Now, whenever patent has been filed, then it will be published in some form. Okay.
Sir, we are absolutely running absolutely on like about to end the like session. So, sir,
Okay.
kindly if you wrap it up so that we can attend 1-2 questions.
So there will be something like this where the review report will be coming, and again patent attorney will be filing with the response, and ultimately again it will be going to a public domain, and its documents will be coming if it is granted, patent is granted. So there will be certificates of granting also will be there. The institute name is there in the name of the institute also. Simultaneously you can put the your name also in the cost of money. So almost 2,000 rupees they take. So after granting the patent, it will be, you have to maintain the patent for the 20 years. Every year, let's say it's take 1,000 rupees. So instead of individual filing, the institute name is very good because institute pay everything. Now it is 1:27, 26. If 1 o'clock, okay. If somebody has any question, can ask me.
I think after Sir's illustrious explanations of step to step how to file a patent, I think Sir has already answered Ajay Kumar Dash's question that if it is not done this way, then it might get rejected.
If it has not been then drafted properly, okay, drafting is very important.
So with this, we make the house open for questions. If you have any question, I think Sir has been constantly interacting with the participants, and most of the questions of the like type to type slide, how he has moved through his lecture has already been answered. Apart from that, if we have any questions, we can take 1 or 2 questions.
Anyone? Or my email ID, phone number is there. Always can interact. I'll be happy to. Okay, answer.
So, sir, I think there are no more questions. I think all you have clearly answered all the queries that might have come up. So we think our chat box is flooded with thanks for you. So, sir, so for such an interactive lecture. So with this, we come to the end of the lecture of 2 consecutive lectures by Professor Pradeep Paik on engineered novel polymeric nanomedicines for therapeutic applications. We are extremely grateful to Sir for he has extended his discussion on very practical sides that might come up with patenting and other things. So we are very much thankful to Sir. I would also like to thank all the participants who have actively interacted in the entire session. So thank you, sir. And with this, we will be breaking for lunch. At 2 p.m. sharp, we will be here with the lecture to be delivered by Professor Krishnendu Acharya.
Thank you very much for listening to me. Okay. And
thank you so
lot.
much, sir.
I also will be going for lunch. Okay. Thank you.
Okay, sir. It was very nice to have you with us. So thank you so much,
thank
sir.
Thank you very much. Thanks. All the best to you all. Okay.
Thank you so much.
I'm just logging up. Okay.
Okay.
Bye.
Thank you so much, sir.
Bye. Bye.
Bye. Bye.